living on a disk, floating through space, with a tiny sun.
Hey, I'm FTFE and welcome back to the channel that shoves stupidity into the trash compactor of science. And I'm back. I know I've been away for a few days, but I'm here again to show you some stupid. What fun. If you have not seen the video released today, then please do check out episode 60 of Flirfs Are Idiots, starring the one, the only Mrs. Fight. Yes, you will get to see my wife in all her beautiful glory, presenting the show way better than I ever could. According to the comments, they just want to replace Emma with me. Screw Craig. No Craig, just have Emma on the channel. I understand. She is the, well, you know, better half of this relationship. So if you would like to check out episode 60, just go and look at my videos that have been released today and check that out. An absolute destruction of Eric Dubay. Thank you everyone for joining for another Flat Earth debate. Today we are going to be discussing the nature of space, you know, because flat earthers never understand that. With me today is someone who's been on the channel a couple of times. It is Effed Up World. Effed Up World, how are you doing?
I am good, as well as I could be. So no complaints here. How's Craig doing?
Craig is living the dream. Loving the fact that we're here discussing the shape of the Earth in the year 2021. It's only 4 fucking months till 2022, guys. I'm still trying to process 2020. What's going on?
I'm like back in 2015 or something.
Yeah, I don't think I ever got past 2019 mentally. For that's for sure.
I hear you there.
Charisma and the Derp Squirrels, I missed you too. I have been away for a few days. Honestly, I've been dealing with my mental health. Struggling a little bit. I do suffer from chronic pain, 24 hours a day. It never goes away. Serious pain in my shoulder and my knee, and sometimes that is my entire world, and I've struggled quite a lot recently. So yeah, I've not done a stream for like over a week or something, so I'm doing all right. I'm getting there, guys. Thank you for the kind words and the support. So I do appreciate that. Anyway, Effed Up World, you would like to talk about space and the nature of, yes?
Yes, I think it'll be interesting conversation anyway. I really don't think that we're entirely in disagreement on everything. I think that there's a lot that we probably both agree on as far as the nature of what we call space. Do you want me to just talk for a minute here?
Yeah, why don't you just explain to everybody your position on what space is?
Okay. Well, in order to debate about what space actually is, we need to know which space are we talking about. The one that appears to be stuck to the Earth, like the atmosphere and even above, but or is it the one that's moving at orbital velocity? Because I see two different kinds of space, and they might be in the same place. Oh, go ahead. Did you say something, Craig? Sorry.
Yeah, two different types of space, did you say?
Yeah, and you know this too. What happens if I was to send a rocket straight up in the air, like towards zenith, you know, straight up? What would I expect that rocket to experience?
It would go up and then come back down.
Come right back down. It wouldn't. Yeah. It wouldn't see any kind of, you know, sideways.
No, because you have to travel in a sideways velocity to get sideways momentum, which is the reason.
Exactly.
Why
yes.
Here's the rockets.
So you have
away from us.
You have the okay. If Earth is a globe and it's rotating, then you have the atmosphere that's kind of glued to the Earth, or it appears to be. If it's rotating, it appears to be rotating with the Earth, and from the ground, it appears to just be still, right? A helicopter just sits and flies, and it's not affected by really anything other than gravity, right?
Yeah, I mean.
Okay, now and that's in the air.
Gravity and friction is what, you know, keeps the atmosphere moving in footstep with the Earth's rotation.
Yeah, that's what would be the answer, right? Friction or like basically if it's always turning, then it's just always going to be turning with the Earth.
Yeah.
I'm guessing.
Yeah. Well, you got
Yeah.
to think that the atmosphere has been attached to the Earth for billions of years, with the Earth rotating. And if you imagine getting a bucket of water, right, and you just put your finger in the middle of that bucket of water and start doing small circles as fast as you can, eventually the entire bucket of water will be spinning the same angular velocity as your finger, just doing little circles in the middle, because the friction
Those round
of
pools
each
that
water
people get,
molecule. Yeah,
you can go around the outside of the pool, and eventually the
yeah.
whole pool is spinning.
Yeah, exactly, because the friction of each
Yeah.
water molecule next to the other one is dragging it along, and over time it's going to make it have roughly the same angular velocity at the outside as it is in the inside. Now imagine that bucket with the water spinning, but without the bucket, so there's no friction. There's no reason why the atmosphere would ever stop.
Without air, things just freely move. There's nothing pushing back on them, right? So what you're saying?
Yeah.
Basically, yeah. So I think we agree on that. But there's a few things that I got to point out about this other. This is what I'm saying. There's two different kinds of spaces. One that moves with the Earth, even if it's not in the atmosphere. If you send a rocket straight up, you can send it way higher than the atmosphere. You can send it up to however far, and it's still going to come right back down. It's not going to be stuck up there. It's not going to stay up there. It's not going to display any kind, momentary, or for a short period of time, it'll be on a ballistic trajectory, and there will appear, if you were inside the rocket, there would appear to be some the state of free fall.
All right, just 1 second, guys. I've altered the volume on my mic, so let me know if this is any better. I've got a new mic.
I can hear you much better.
Right,
I've
just upped the volume on my side, so maybe it's a little too loud now because it's peaking. We'll see how that goes. All right, sorry, carry on.
No, that's no problem. So then, here's an example of kind of what I want to talk about is on the way to the moon. They were experiencing, they were in a state of free fall, as far as, or essentially 0G floating.
Yeah.
And that's because they're orbiting the Earth, and this is like, I don't believe that anything's orbiting like in that way, but myself. Yeah. But as far as for this conversation, the understanding that us human beings have of what orbits are, and like delta V, what it takes to get into orbit. That's all very real stuff as far as I'm concerned. I don't think there's anybody faking anything like that. I think that the limitations of our technology, when it comes to power, it is one of the hardest things possible is to escape the Earth, to leave the Earth.
Yeah, that requires a lot of energy to do that. Yeah, which is why it's so damn expensive. And the technology
to make that safe. I mean, even it doesn't appear it's not really safe anyway. But they routinely do these things safely. There hasn't been a lot of death that's happened. I mean, there's been some, but there's not a lot. That's for how many people have gone on these rockets or the shuttle, and they've gone to these crazy speeds. Very few have died. So what I'm saying is that generally I would say it's very safe what we have done up there. But what I would point out is that everything up there, and I mean everything, even if it's not man-made, whatever's up there is in a state of free fall. So
if it's in an orbit, it's in a state of free fall.
What's that?
If it's in an orbit, it's in a state of free fall. Yeah.
And and I agree. And what I'm trying to say is that saying that if it's in a state of orbit or if it's orbiting something, everything that exists in the sky that we know of is orbiting something, isn't it? I'm saying it's all in a state of 0G or whatever.
Yeah. Technically, everything is kind of orbiting something else. The moon's orbiting the Earth is orbiting the sun is orbiting the center of the galaxy. The center of the galaxy is orbiting the Great Attractor. You know, there's orbits within orbits within orbits. So yeah, you're right when you say that everything's in a state of freefall, which is why
that's
there
basically
appears
the
to
point I'm
be
making.
no
It's
gravity
not
because
tricky.
it cancels out the acceleration of gravity.
Yeah, and you end up with that. And that's
Yeah.
I understand your understanding of it. You know, like if you're gonna travel, there's math that we could do to, you know, the curvature of the Earth, add 250 miles in altitude, and that's the trajectory that you have to ride on to orbit a globe, right?
Right.
As far, I mean, that's orbital. That's the lowest orbital velocity that is possible. Is
So
if
what's
something
your
will
point
stay
with all
up
this
there.
then?
You know what I mean? And what I would like to bring up is that I understand that, and that makes total sense, and that's what I think everybody understands it to be, is like the moon is going around the Earth. And hey, I see Spare Room Music in the chat. What's up? He comes to my channel once in a while. I think that there's a few. Okay, let me bring a few things up if I can.
Yeah, please. Let's
okay.
bring up some evidence of you know,
Okay. On the Earth, we have air,
yes.
and in space, it's very similar, as close to a vacuum as we could probably get, I'm guessing.
Yeah, let's say 10 to the negative 17 torr.
Yeah, and what I mean as far as that goes is a vacuum isn't really possible to have.
No.
I don't think.
No, there is no perfect
you know what I mean? It's a
vacuum.
concept.
Yeah.
Yeah, it's a concept. But we can definitely take a container and pull as much of everything out of it as we can, and
Yeah.
you know that, and try to mimic that. But what I'm saying is that if there was a true vacuum, then there would be no space in it. Theoretically, right? I'm saying we don't have a way to make a vacuum. Like
No.
100.
No,
like
there is no such thing as a perfect vacuum.
Yes. So what I'm saying is,
So if we want to
it's a
talk about
concept.
definitions, right? Space, the entire universe is just a extremely low pressure system. You know,
Yes.
that's the best way to describe space in general. Space has
Almost
got
no
stuff
pressure.
in, so it's not a vacuum, but it's really, you know, the average of the pressure throughout the entirety of space is so low that we can just say that space is an extremely low pressure environment that can be, you know, for all intents and purposes, classed as a vacuum.
yeah, definitely. So essentially, there's no air in space. I mean, there might be a little bit, but like the ISS, it doesn't really get much drag coming at it. It's
No.
basically, it doesn't need to boost itself very often. What I'm saying is there's a place up there that, unless you're moving sideways at what we call orbital velocity, it doesn't really exist. I mean, the
No,
place
what?
might exist, but here, let me ask a question. This will help. Let me ask you a question, Craig. Okay.
Yeah.
Has anything
Okay.
ever entered the Earth's atmosphere that you know of that wasn't moving sideways? Like that wasn't moving
Wasn't moving sideways.
close to parallel to the surface of the Earth?
Well, there's plenty of comets that don't come sideways.
Enter the Earth, I mean, enter into the atmosphere.
Yeah, there's plenty of comets and meteorites that enter the Earth's atmosphere that don't necessarily come sideways.
How fast are they moving?
I don't know.
They're moving sideways, as far as I know. I don't think that they could.
Sideways compared to what?
Well, if we're like, they're moving sideways compared to the surface of the Earth. They're moving parallel with the surface of the Earth, but above it.
No, not. I
Almost
mean,
parallel.
comets don't always come in parallel. They're, you know, comets and meteorites quite often just come on a direct downward course straight towards Earth.
I don't think a comet has ever come into the Earth's atmosphere that I know of, but a meteor maybe is what.
I've got plenty of yeah, a meteor. You know what I mean, like objects from space.
Anything that, yeah.
Yeah, there's
that's
plenty of
better.
videos
Objects in space.
showing you know, meteors coming in directly and not at like an angle.
Or like maybe the what's the that just happened kind of in the middle of August. Perseids.
The Perseid meteor shower, yeah, that's
Yeah,
because we passed through
they're coming out.
what's
They're going
left
out
over
different directions,
from
kind of.
Halley's Comet, is it, or Hale-Bopp, one of the two? We passed through the tail that's left from it.
Yeah. So, like, I'm thinking of like on the way to the moon. Obviously, they fire a rocket engine to get to leave the Earth to stop orbiting the Earth, right?
Yeah,
Then,
if you want to escape the orbit, you need to shoot your boosters to escape
yes,
the orbit and head in a different way.
to get a different orbit. Yeah.
Yeah, I mean, but like they generally use the orbits to help escape the orbit. So, they do a gravity shot. Basically, they're coming quite close to the Earth, get a really big bit of acceleration as they're going round, and use that acceleration that they've got from getting closer to the Earth and increasing their velocity to escape
Kind of
the orbit
slingshot.
and head off. Yeah. It's
Yeah.
what Voyager did to leave the solar system through Jupiter and everything. It's what it's just I don't understand your point here, that you're saying there's
place.
two different
There's a
types
place
of
above
space.
us that's moving. That not itself is moving. It's like a medium, is what I'm saying. It's like a medium, and we call it a vacuum. But
Yeah, but
in order
that's not
to-
moving though. The things in it are moving.
Yes, but there's also no like no drag. Do you know what I'm saying? It's nearly
Yeah,
a
because
vacuum,
there's no
and-
friction. Yes.
Yeah, no friction. That's what I mean. And so the only way to reach that place where there's no friction and where there's like a 0 G effect, or the state of free fall, is to be going orbital velocity. So what I'm saying is that everything that's in space, that stays in space, has found or is finding a orbital. It's trying to find
Yeah, it's
orbital
called
velocity around
it's called
something
orbital
else.
mechanics, and it's pretty well understood. It
Yeah.
doesn't change the nature of space. Space is still space with things moving in it. Space itself isn't moving.
Well, the stars in it are moving, right? I mean,
No.
from here they are.
I mean, everything is moving. Yeah, the stars in space are moving. The stars in in our galaxy are orbiting the supermassive black hole at the center of the galaxy, the same as our star. But
Have you
that
ever
doesn't
seen
mean
that black
space
hole?
is. I've looked. I've looked along when I was near the equator. You can look in the night sky and literally see the disk of the Milky Way and the bulge of Sirius in the middle. So yeah, you have seen the black hole that exists at the center, but it's the things in space that are moving. The stars in space are moving, not space itself.
Thank you.
But that's my point. What's
That's
what's your
exactly what
point?
I'm saying. I'm not saying we're going to disagree on everything, Craig.
Wait, so you
What
agree
I'm
that
saying
space is real and it exists as we say it does?
It does. Well, as far as any human being is concerned, the only experience, or the only thing we can learn about it, is by sending a rocket up there and letting things float around up there and learning how to maneuver
Yeah.
them around and to different places and all the properties of what's up there, right? But we wouldn't learn anything. We wouldn't know anything about it if we didn't put things up there or go up there ourselves, right?
Well, yeah, that's the idea of the ISS. That's why we've been in low Earth orbit for 20 years, figuring out, what happens in space. But Joe,
And it looks like a globe from space.
Yeah, I mean, that's because it is. All right, okay, let's do this, because I'm really struggling to kind of pin you down to a point here. What is the
Okay.
differences between what we say space is and what you say space is?
Well, how about if I bring up that the things that we agree on, if I bring those up too, I think that is just as valid. But there's no air in space. Like it's not a place
Yeah.
anything like with an atmosphere like the Earth. Okay, that's a difference. But essentially, no gravity because, like, what I'm saying is that this is the okay, everything that's in space that's staying in space is moving sideways parallel to the surface of something else, orbiting it, right?
Yeah, I guess.
So what if we took out the orbiting it part? Because it's hard to actually know if something's orbiting something if you can't see the whole thing. Like example is
I mean,
the ISS.
we know that things are orbiting things. That's orbital mechanics, celestial mechanics. You know, that's
yeah,
that's what it is.
So-
We've observed
so do you-
these. Not
Do you
only have we
observe the
observed
Earth
the
rotating around the sun, or is that just basically
yes,
built off of
yeah,
knowing
we quite clearly
what
observe
stars
the
look
Earth
like?
orbiting. We quite clearly observe the Earth orbiting the Sun. I mean, I observe that every day when I look out
you
at the
tell me
Sun and see
how?
what's happening.
Can you,
Well, you-
tell me
you
just
can-
briefly?
You can model out the position of the Sun throughout the year, where it rises, where it sets, how long it's in the sky. Compare that to your latitude against and the tilt of the Earth. You can see based on those observations that you are orbiting something with a specific, that's been mapped out. We know the Earth has an elliptical orbit. We know where it's traveling the fastest. We know where it's traveling the slowest. And we can compare what we see on Earth to what we've modeled out, and the observations match. So whenever I go and observe the sun rising and the sun setting, and it doing it in different places, and compare that to everything else that happens in the sky, looking at the stars and everything, the observations match a Earth orbiting the sun. That's what we observe if we compare it to everything else.
Okay, I can't disagree with that because I think to disagree with that would be to call everyone not logical and me the only logical person. So that would be. I'm not saying that it doesn't make sense.
Right. Okay.
It does make sense.
So, I think the problem here is that you're a little bit stuck on Einstein on Newtonian mechanics, right?
Okay.
And how that defines what is happening in space. I find a good way to think about things is actually moving more towards an Einsteinian point of view. Now, if we're talking about things in space, let's take the Earth, right? The Earth is traveling on a straight path through space, right? Through space-time. Everything is traveling on a straight path through space-time. So let's say the Earth is traveling on a completely straight path through space-time, but space-time is curved because of the mass of the sun. Right? So even though the Earth is traveling in a straight path, because the space it is traveling in has become curved due to gravity, it changes the apparent direction of the Earth. So It's not really the Earth that's doing something, it is just following the contours of space-time that have been warped by the extreme mass of the sun. So
like
if
water
that sun...
running down a water slide, kind of, it just
Almost,
goes
but if
down.
the sun wasn't there, the Earth would go in a straight path, right?
Okay.
But because the sun is there, because it has warped the space-time around it, that straight path that the Earth is traveling has become curved, because space is curved.
Now,
Does
is
that make sense?
an idea, or is that something we can verify?
Well, that's been
the
verified.
curvature of space or whatever.
The
that is,
curvature
I'm
of
saying.
space has been verified many times. The best way that it was verified was with the Eddington experiments of 1919, where they made predictions of what stars they should be able to see near the sun. And they waited until there was an eclipse that allowed them to see the stars that were close to the sun and actually measure the difference in the position as the light from the stars went past the sun. And it showed that the mass of the sun actually changed the apparent position of where the stars were, showing that the space was warped, and even though the light was traveling in a straight path, the apparent position of where that light came from changed when it intersected with the warped space-time of what the sun has done.
Okay, then
There's gravitational
you know,
lensing. You can talk about the Pound-Repka experiments and how that kind of confirms a lot of Einstein's predictions, around the way that gravity would affect anything with energy or mass. There's many experiments that have confirmed that space-time is a medium that can be manipulated by mass. Everything in the universe is traveling on a straight path, but because the space-time that it's traveling in is curved, they follow, the curved path of space-time. But for them, they're traveling in a straight line.
so is that same for the moon? So the moon's traveling
Yeah.
a straight line, but the Earth
Yeah.
is curving the space.
Exactly. The Earth, the mass of the Earth is curving space-time. So the straight path of the moon is traveling through a curved space.
Okay, that's interesting. I have not heard it explained that way to me before.
That's what I'm saying.
That's
I think you're kind of you're kind of stuck up on the misunderstanding of the Newtonian side of things. And even though, even doing a degree in physics, you don't really touch on a lot of Einsteinian principles. You still kind of stick with Newtonian. But sometimes understanding what Einstein was talking about helps visualize what is actually going on in space. You have to see space-time as this malleable thing that can be warped and changed based on the mass that's near it.
Okay. Yeah, and that's something I don't really know about, but I guess I don't think I misunderstood about what happens when we send something up there. And it's not like I'm super interested in it or that I'm a professional or a scientist or something, but it's just something that I've learned a lot about in the recent years.
Yeah.
But the thing that I see a distinct difference between just or let's put it this way. I see an additional place, and that is that sideways, whatever you want to call it, that zero vector or whatever.
It's not really a different place, all right? The only difference between down here and up there is that there's an atmosphere here, and there's an atmosphere here because the warped space-time that the Earth is causing is making, all the particles move towards that. But they don't have enough, tangential velocity to orbit, so they're stuck to the Earth because of gravity, because of that warped space-time. They're moving towards the center of that. And that's the only difference. There is no difference in the physics between what is down here and up there. Physics is the same, because we have to take into account things like the atmosphere.
I could point out some things that are different. And it's not like you don't know these things. There's no air there. And then
but that's not a difference in physics. That's the physics of the universe is still the same. Whether there's air or not, physics still works as we expect it to.
And I don't doubt that. As far as like whatever it is up there, if we send a rocket up there, it behaves a certain way, and we have data from that, or whatever videos and whatever, we understand how that's how Elon Musk is making them come back down and landing them, because he said they didn't land their first one. You know what I'm saying? Everything is learned by doing, as far as space stuff goes.
Well, that's the point of doing stuff, is that we learn how to do it. That's why Elon Musk has done so many booster tests and stuff and had a bunch of shit blow up, because he's learning how to not blow shit up. That's the entire point of it, right?
That's it's an obvious step in the direction of going into space, right? That's the whole point that's what Elon Musk says, is that he wants to, in order to do anything, to have any chance of going to Mars or anything like that, he says we need to have rapidly reusable rockets. And so that's what he's tried to do with SpaceX.
Okay,
and
so
they've done pretty well.
So the audience is asking, and I do have to ask again, what is the point here? What is the contention you have with what we say about space? I
Is
know
it
I
it's a
know
place
you
with-
you agree with a lot of things, but what do you think is the, you know, what do you think that what we say is wrong?
I don't necessarily think that what you're saying is wrong or what we're no, I'm not saying it's wrong. I'm saying that what if what if it's misunderstood and some of the things that we assume, like you're talking about, what that's why I brought up, do you see how do we know that the earth is orbiting the sun? Because we actually see the sun going over the earth like every day. I'm saying, so it's an idea that earth is orbiting the sun, and the way that you would come to that understanding is because of the position of the stars, and you get back around after a year and the position of the stars is in the same spot in the sky, and you realize that's why you think you've gone around the sun, right?
Yeah, I
I'm
mean,
saying it's
not
all
completely the
determined by
position of the
looking
stars
up
do.
at the sky.
Well, yeah, but also the fact that we've been there and we know what space is, and there's no real, question about that. We understand the physics of space so much so that we send probes there all the fucking time. I
And it just so
I
happens to
don't.
work out.
It just doesn't just so happen to work out. There's been billions and trillions of dollars and pounds and euros and Russian money or whatever spent
No, of
in
course.
researching this. That's
Yeah,
why
but what
Russia
about
sent up
why is there such
the
thing
Sputnik
as
one.
low Earth orbit?
Why is there such thing as low Earth orbit? Because you
That's
can be
figuring out the
relatively
key
low
to
to the
another
Earth.
world, basically.
It's not figuring out the key to another world. It's I mean, that's a way of putting it, I guess. That's
Well, how
very,
did that? I
very,
mean, that's
very
how we
romantic.
figured it out. That's
but
how Russia sent up Yuri Gagarin, and
yeah, I mean, that's the point.
they
right?
all had to go
we
sideways
do everything
in order to
we do everything
experience
to
that place.
learn, and yeah, you have to go sideways to maintain an orbit. But that's the physics that we expect. That matches what's down here on Earth, even on
And
Earth,
it's also
right?
that's a good
Right,
good
wait.
place
Let
for me to
me get this right.
explain-
Even on
sorry.
Earth, an orbit is a thing that would exist. All right. So let's imagine that you're standing on Earth and you throw a cricket ball forward. What's going to happen to that cricket ball? It's going to go
fall.
forward and it's going to arc down, right?
Now shoot it really fast.
Yeah. Now throw it as hard as you can so that that arc it makes matches the arc of the curve of the Earth,
the
right?
curvature of the Earth.
And that's
And
what
then
an orbit is.
you
Now,
just continuously fall.
yeah.
Yes,
Now,
I
obviously,
understand it.
in the atmosphere, that cricket ball is going to lose energy because it's rubbing against the atmosphere. But
Yeah.
that's why you go up high enough in the gradient of the atmospheric pressure to reduce
Where
the
there's no
friction
pressure
to make
almost,
sure.
and
Yeah.
there's almost no pressure, and you go much. You don't lose your velocity.
Yeah, but that's and there's nothing different about that. That's the physics that we expect. I mean, if you go up to the top of Everest, there's less friction in the air because there's less
Yes,
pressure.
less air. Yeah.
It's that, and
I've climbed
that's
a
all it
mountain
is.
in Colorado before. I think it was like either 12 or 12,000 feet, I think, or something. It was so hard to breathe up there. I didn't even want to stay up there when I got to the top. I was like, I want to go down now.
Okay.
I could
So-
not breathe.
QED in my chat says that you think, is this right? That you think that the rocket is matching the speed of the space that's moving around the Earth?
No, that's not what I think. I don't think the space is moving. How would you know it was moving anyway, right? What I'm saying is everything in it has, like, if you like the ISS, for example. How can I go on my cell phone here and know what time the ISS, precisely what time the ISS is going to literally pop up in the sky above my house? How do I know that?
Because we can model
there
things
be an app
based on.
that has that? It's because
because-
it's on a very predictable path, and
Yeah,
nothing's going to stop it from that schedule. Correct?
Well, I mean, there could be things like recently they
Well, but
accidentally
in
they
general.
accidentally fired some boosters and sent the ISS into like
Yeah.
a spin, and they
spin,
actually
yeah,
lost
that-
they lost nearly 14 miles of elevation during that.
Yeah. So they had a rebooster after that.
Yeah.
Reboost after that.
But
yeah.
but okay, so
And they said it was only 45 degrees. Yeah, right. It was not only 45 degrees.
but
So let me
but
just hear me
nothing
out
you're
for a
saying
little
nothing
bit
you're
more.
saying disagrees with the globe model. That's what I'm confused about.
So then let's consider it. Now I know you don't like the flat Earth, but just consider what I'm saying, why
Oh, I love the
I'm
flat Earth.
understanding it a different way, if you
It's
can.
fantastic.
So an orbit requires curvature of the body that's attracting whatever, causing it to orbit, right? In space, I'm saying, it's like on the globe model.
Right. So you're
Low Earth
saying
orbit
that
is going around the globe, right? So what would that mean if it was flat? It would mean a circle, right? It would mean a circle above the sky, or above us in the sky, a huge circle.
Yeah, but you can't orbit above a flat plane.
Well, what if you can orbit above a flat plane? What if everything,
How would that happen though? Because there wouldn't
you have
be.
to go sideways?
Yeah, but going sideways would make no difference above a flat Earth, because the going sideways is so that it misses the curve.
Misses the Earth.
You know, and
Yeah, I
goes
know
around it.
that.
But if there's
What
something
I'm
above
saying
us
is-
just going round sideways, it's not orbiting anything. It's just going round in a circle above us, and we would need an explanation
holding
for
it up?
how that is happening.
I'll give you I can't give you an explanation, but I can tell you that there are examples of things in the sky that do precisely that. The sun.
No, it doesn't do that.
It orbits in the sky. Well, it's floating in the sky. Nothing's holding it up, right? I'm saying whatever it is, whether it's 93 million miles away or whether it's right above the clouds.
Well, yeah, but it doesn't go above us. We orbit around we orbit around the
That's not what we
barycenter
observe,
of
though.
the solar system,
We
which
don't
is
observe
actually
ourselves orbiting around the
it's
sun.
about. We do. We really, really do. It's quite easy to make that observation if you do it over time. It's clear that that's what's happening. And technically, we're not really orbiting around the sun. We're orbiting around the barycenter of the universe, of the solar system, which is about 1 million miles off of the center of the sun. Interestingly,
1,000,001, I heard.
yeah,
I'm
roughly.
Just kidding.
I mean, it's but
So-
you
so
you
if it was
can't
flat-
have an orbit above a flat Earth because there's no reason for it to stay up there. The
But
physics
that's
isn't
the point
same.
I'm making, Craig, is that there is a different. I believe that the Earth is flat. I don't think that's any mystery. But
And it's not, but yeah.
understanding that, I'm just, if you can just put yourself like in that stupid frame of mind that I have, if you can do that for a second, you might understand what I'm saying. Everything
Well-
that goes up in the sky just comes right back down. You throw a rock up there, shoot a bullet up there, it just comes right back down.
Yeah.
But if you send it sideways, if you send it parallel to the surface, just listen, Craig.
I'm
Look at
listening.
Craig. I'm probably giving Craig a concussion right now, you guys. Pray for Craig.
Yeah.
I'm
please.
just kidding. But if you think about it, what do we observe the sky doing? Not I'm not being too specific. I'm just saying the sun, moon, and stars. Or let's just say the stars. We see them doing orbiting that axis of rotation, right? And I know
Yeah.
that's what it looked like if you're on a globe and the globe's spinning. That's not. But I'm giving a different way to look at it. If the Earth is flat, and it just so happens that you go up high enough, and you move. What's the word? Laterally. Is that the right word? Oh, thanks, Craig, for that. You suddenly you find a point that you're calling a zero vector between the gravity and the outward acceleration around a globe. But what I'm saying is that there's a place above us that is it's a bottomless place. If you go there, you
There's
continuously free fall.
There's a place above us that is a bottomless place.
Bottomless, yeah. Like
Right.
that's what
You
that's what
only
the astronauts are
continuously
experiencing.
free fall if you can have a tangential velocity to stop you smashing into the thing you were free falling towards.
Exactly.
You don't
Exactly.
everything in space doesn't automatically have an orbit or the correct tangential velocity to create an orbit. That doesn't.
It's either got
happen.
a faster one or that orbital speed. It never goes slower than that, or it comes in, or it falls to the ground.
Yeah, you've got to
Eventually, or
have
burns up.
a good enough tangential speed to miss the thing that you are orbiting. But everything isn't, automatically going sideways. If something just appeared above the Earth, a massive meteor just appeared 500 miles above the Earth, it's not going to start going sideways. It's going to fall straight towards the Earth. Going sideways is a result of energy being expended somehow. A lot of the things in the solar system are, because of the way the solar system was created.
About, that huge meteor that you were just talking about, even though it might not be going sideways, it according to the heliocentric idea, that meteor is also orbiting some other body or whatever body, and it's moving orbital velocity around that, right? And the Earth happens to get in the way of it.
Let's just say, right, whatever's happening in the solar system, right? Things falling straight towards things hitting each other, things orbiting each other, whatever's happening in the solar system, the entire solar system is warping space-time, all right? So let's think of the entire solar system as a well in space-time, all right? Now that well, that warping of space-time, that is the thing that is orbiting the center of the galaxy, with everything inside that also orbiting everything else as well, because everything has mass and pulls everything towards everything. But the entire solar system has its gravitational well, and that gravitational well is the thing that is orbiting the center of the galaxy. It's the same if you think of the Earth-Moon system, right? That Earth-Moon system has a gravitational well. That gravitational well is the thing that is orbiting the gravitational well of the sun, which is orbiting the gravitational well of the center of the galaxy.
And that's basically the idea of gravity at the center of something attracting mass, right? That's what that is, basically?
Yeah, the warping of space-time, on a local level, we can break it down to the equation Fg equals G m1 m2 over r squared, and use that relatively simple equation to, on a local scale, be pretty accurate with predicting things. The further out you go, the less accurate Newtonian physics comes, which is why we need to talk more about Einsteinian. But on a base level, those gravitational wells, you can predict what's going to happen with them using the formula Fg equals G m1 m2 over r squared. Mm-hmm. But to understand why that gravitational well is there, you need to go a lot deeper into it.
Okay. So I guess I'm just trying to explain different way to look at it. That's really all I'm trying to say. There is a different way to look at it, Craig. And
I don't see the different way, though. There's not really a different way. There's the correct way and the wrong way. But your correct way has a lot of your own ideas that are not anything that we could actually know. Like you're talking about warping of space-time. That's something we don't. Again, that's been experimentally verified several times.
I don't think so. I don't really think that anyone actually claims that, do they?
Yes, they do. That's what the claims of the Eddington experiment of 1919 are, and the pound replica experiments are. That those are the claims of verifying the curvature of space-time and Einsteinian relativity. Those things have been experimentally verified.
That you can predict with it and that it matches or whatever.
That's how you do science. You make a prediction. Okay, science. Let's break it down to Flat Earth 101. Talk about the scientific method, right? Make an observation. The stars appear to be changing position when they're close to the sun. You make a hypothesis. Well, maybe the space is warped and it's changing the path of light. So then you make a prediction. Well, if that's the case, then if we wait for an eclipse and we can see the stars closer to the sun, we can actually measure the change in apparent position. So you do an experiment. You wait for the perfect eclipse, and you try and see. You know the position of the stars, but then you see the position of the stars close to the sun during the eclipse, and you compare that to your prediction. Out of the way a little bit. Yeah, and it's moved, and that matches your prediction. So you verify your hypothesis, which means that's what you go with.
It doesn't really mean that's what it actually is, right?
According to science, that is what the science gives us the explanation of at the moment. There isn't another
Yes, I
explanation
agree.
right now.
I agree.
If another
and I
explanation
think you'll
comes
agree
along that better
science
explains
is
it, then that's
always
great.
to be challenged, right?
Yes.
That's how it becomes. That's how we gain knowledge, is by learning. Oh, this isn't what it was, and this is what it is. And now I'm not saying that I'm trying to like say that it's wrong. I'm saying that we don't observe a lot of these things that are in your explanation. I'm not saying you're
one
wrong.
sec. I
I'm
just need
saying-
to respond to Protosser in the chat, who says, "Complete
Okay.
word salad, Craig. Try again. Just because you're too thick to understand it doesn't mean that it's word salad. How about you stop being a little coward and come on and debate me like Effed Up World has the balls to?"
And it isn't that hard. Craig's a nice guy. He really is.
No, I'm an asshole. Don't be.
Craig
don't,
can
don't
be
lie.
harsh, and like like Mrs. Fight said, Craig's a idiot. No, I'm just kidding.
Fucking idiot. Get it right.
Yeah.
You know,
and
it
then
was so
I thought
easy
that
for
was
Emma to
hilarious,
deliver that
by the
line.
way. If you guys didn't watch his premiere today, I thought that was hilarious at the end when she was like, "We don't need you anymore."
Oh, right. Yeah.
It was that's good comedy though. I mean, like just the way you set it up, that creative.
Thank you. I do appreciate that. Right. So everything that we say is things that we observe. That's how we do science. We start with an observation, right? So everything.
Oh, no. I'm gonna bust you on that. I'll
Oh,
bust you right
please
now.
go
on
ahead.
that. And I'm only saying this because I know that is what you'd want to be the case, but
I mean, it is, but yeah.
look at what's on my screen here. We observe a turning sky above us.
Yeah.
Every one of us does. So, and I understand. I'm not saying that means the Earth is stationary, and I mean that's what I believe. But I understand what you believe too. You believe that that's what we see because the Earth is rotating, and that's very simple. And I'm not going to like argue with it. We know that we disagree
How does that
on
bust me then?
Well, because we make an observation of the sky turning from a ground that's not turning, that appears in
so
every way to be stationary.
That's the observation, right? So yeah,
Yeah.
we make an observation, and the things in the sky appear to rotate around a central point. Two
Yeah.
separate points actually, depending on where you are on the Earth. No one disagrees with that as the observation, but then we go to the next step and we form a hypothesis from that observation. So yes, everything that we say starts with an observation. Whether that observation is an instant agreement with what you think is irrelevant, you have to follow science to figure out what it is. Yes, we observe the stars rotating when we look at them, but then we have to form a hypothesis as to why that happens. The observation is just the very start. Yeah.
So where would we
hold on. Let me explain. Let me
explain.
explain. Yeah. Let's walk through it. All right. Let's say that we observe all of the stars in the northern hemisphere rotate around the central point of Polaris. Absolutely, 100%. Everybody can agree to that, right? So what's the next step in science after making that observation? What do we do next?
You form a hypothesis, right? Is that what you're saying?
So what's your hypothesis?
I don't know. That's where I'm not a scientist, and like
that's where it falls down though, because that's what you have to do. You can't just stop at the observation and go, oh well, that's what we observed, so that's what I'm going to go with. You have to follow science, and you don't have to be a scientist to come up with a hypothesis. I can do it for you. All right, your hypothesis.
Shout out Nathan
would be,
Thompson in the chat. Be the change. What's up, bro?
Sorry. I get that reaction whenever Nathan's around.
No, so Craig, like, here's what I'm saying.
I can smell him from here. He's in my chat, and I
hypothesis-
can actually smell him.
Is the hypothesis something that completely disagrees with the observation?
The
Or would
hypothesis
it
can be
would
whatever
you make a
want it to
hypothesis
be.
that agrees with the hypothesis?
Well, that's the point, right? Your hypothesis can literally be whatever you want it to be, as long as it is something that can be tested. All right.
So what would our hypothesis be?
From
like
a flat
if
Earth,
it's a globe.
right?
You know what I'm saying? Like, where would we go?
Okay, so
from
you want
here?
to do this for a globe? Right, fine. Okay, so we observe the stars rotating around a central point of Polaris when you're in the northern hemisphere. The globe hypothesis for that is that we are on a rotating body with an axis of rotation that points towards Polaris. That is the hypothesis for the globe.
Yeah.
Okay. Now, what would the flat Earth hypothesis be?
I don't think I guess I don't really know what how would it be different? What are you saying? That you're just saying that the axis of rotation.
My hypothesis
I would say the
is
axis
that we're
of
on a
rotation
globe.
is in the sky, not on the
Well,
Earth.
yeah,
It's in the
yeah,
sky.
okay, right, okay, but right. So again,
That's the
my hypothesis for the globe is that we are on a rotating body with an axis of rotation that points towards Polaris. That is my hypothesis for the globe. If you are bringing up a hypothesis for the Earth being flat based on that observation, what would the
It would
hypothesis
be that that Polaris is in the sky, and that the Earth, the sky, the stars go around Polaris
Right. Okay.
from the ground.
So
yeah, I mean,
So
I don't have to go to a
hypothesis-
spinning globe to
your
have an
hypothesis is that no, you don't have to, because that's not your hypothesis. Your hypothesis is that the Earth is flat and the sky is rotating above us, right?
basically, yeah.
Okay.
I mean, the
right.
Earth doesn't show us any signs of movement, and it appears that the sky is turning above the Earth. I mean, that's what we all experience.
Okay, so the next step of of science, if we're we're obviously talking like high school level science here. There's a lot more to it when you actually get out in the field, but we're stick with what flat earthers love to go on about. We're stick with that. Okay, so we've got the hypothesis. The next step is to test that hypothesis, right? And we test the hypothesis by making a prediction that is exclusive to our hypothesis.
Okay,
that
and how
can be experimented on. Okay, so
let's do the globe. Let's do the globe first, and then
okay,
try the
so
flat.
excellent prediction for the globe. If we are on a rotating body with an axis of alignment towards Polaris, then if you were to use an instrument that could measure the angle between the horizon and the stars in the sky, and you measured the angle between Polaris and the horizon at the North Pole, based on what we say the Earth's circumference is, for every 69 miles you move away from the North Pole, Polaris will dip 1 degree in the sky. That is a prediction that is exclusive to the globe. That prediction cannot work if the Earth is flat. If the Earth is flat, wait, let me explain. If the Earth is flat,
I'm sorry.
If the Earth is flat, then for every 69 miles moving away from the North Pole, the degree of change will not be 1 every time. That only works if you are on a globe with a curved surface looking at something extremely far away. If the Earth is flat, for every 69 miles away, the change in degree will get bigger each time. So first 69 miles might be 1 degree. The next 69 miles, it will be more than 1 degree. The next 69 miles, it will be more than 1 degree. So we've got
Wouldn't
two
it go
different...
the opposite of that? Wouldn't it be less and less and less? I think it would be less and less and less.
Yeah, no, you're right. Sorry, it would be less and less and less.
But either way, but I know what you're saying.
Right,
I know what you're saying.
So what I've done
prediction
is
would
I've
be-
come up with a prediction that's exclusive to the globe, because if the Earth is a globe and we're looking at the stars that are still on, we're rotating, then every 69 miles will equal 1 degree in the change of position between Polaris and the horizon. That is an exclusive prediction to the globe.
Okay.
Right,
And
so
I
then
would
we test
say
that.
an exclusive prediction to the flat Earth would be something very similar. And the reason why I'm able to do this is because we already know that the sky changes in position. The stars in Polaris will say changes in position in the sky a degree every 69 miles.
But why? You have to have, not only
Because
do you have
if you're
to have
moving away from something, this is like predictable, and there's math to this too.
Yeah, but
What I'm
the
saying
math
is-
doesn't work on a flat Earth, though. You have to have something that is not only predictable but has a explainable mechanism behind it. There is no reason, if the Earth is flat, every 69 miles would equal 1 degree and change. Those
there
things
is. If-
don't.
if
That doesn't make sense. It simply doesn't make sense. The maths for that does not work. You cannot on a flat plane
you also
have
say that the
something
sun
changing.
should get smaller than as it sets. The size.
If the Earth is flat, it should, yes, which it doesn't.
No, and I don't think it should. It's not.
But it should. If the
that's
Earth
what
is
I'm-
flat, then it should, because it's moving away from you.
Well, what I'm saying is that the sun and the moon are not the same as an apple. They're lights in the sky. What I'm saying is that you can't say that the sun, or I mean Polaris, let's say, you can't say that Polaris is a certain distance until you've decided on
it really
your
doesn't
map.
matter what the distance is, right?
Well, it does make a difference though, because if something's 10 feet up in the air above my head at zenith and I move 5 feet away, it's going to change its position a lot in the sky.
Yeah, but
Apparent
the way that it works in reality is that it's 1 degree for every 69 miles, which simply mathematically does not make sense for a flat plane. There is no maths that could back up that observation and prediction if the Earth is flat. It simply does not work. You cannot, 100% have a 1 degree change for every 69 miles of distance if the Earth is flat. That is the prediction exclusive to the Earth being a globe.
Okay, and I guess I disagree with that, your math. I think we should do the math then, as far as how perspective works. We should like briefly go through how that math works, how much something shrinks in angular size as it
so you would need to use the equation, or do you know the equation for that?
No, I don't, and I'm not an equation guy, but I mean I can understand them.
So if you want to use the maths for it, the maths to figure out how big something should be based on how far away it is alpha equals 2 times the arctan of g over 2r, where alpha is the angular size of the object. Let me explain. Alpha is the angular size of the object, g is the distance to the object, and r is the actual size of the object. So using alpha equals 2 times the arctan of g over 2r, you can calculate exactly how big something is supposed to be based on how far away it is.
Okay, and I think I screwed up because I'm not as concerned with how big it is supposed to be, because an airplane or something would work on that equation, but I don't think that the sun and the moon, maybe even the ISS, things that are up there don't seem to be affected as far, like it does seem like there's a personal dome of like around us that we see.
Shut up, Jeranism.
And as we travel, we can see, different areas of the sky. What I'm saying is that when I go from here down to, I'm in Minnesota at 45 degrees. When I go to Florida, the moon changes position, Polaris changes position. It goes down towards the horizon because I'm going away from it. I think it would be hard to actually take points and do, like, your claim is that you're getting 69 miles every 1 degree. Well, It's hard to do that if there's terrain on the ground, because it's hard to find a flat. How would you know a flat part of the ground where you could do that from? What's that?
Do it at sea.
I couldn't hear you. Sorry.
Do it at sea.
Yeah, do it at sea. And then if you do, you're saying if a ship sails 69 miles, it's at a 1 degree different latitude.
Yeah.
Yeah.
Right.
And I guess I would just, I would say, oh, go ahead.
So, this is a flat Earth, right? Just quickly, all right?
Mm-hmm.
And each one of these lines is 69 miles away from the North Pole, which is here, okay? So at the North Pole, you've got Polaris directly overhead, all right?
90 degrees.
Yeah. So for every 69 miles, you would have 1 degree of change. So this angle here would change by 1 degree, all right?
Mm-hmm.
But on the flat Earth, it's not 1 degree each time.
Okay, where did you measure this?
I'm just doing simple angles there.
Well, that doesn't.
You can see it's not. It wouldn't be a 1 degree. It wouldn't be 1 degree change each time.
Changing a degree, right? 1 degree on each of those lines, right?
So
1 degree on each one of those lines in a different position. You're saying that the math doesn't work out.
No, it absolutely doesn't, because it would not be a 1 degree difference each time, right? A 1 degree change. However,
how much would it be?
it changes the further away you get, right? But on a globe, that's 69 miles for 1 degree works out every single time. No matter how far away you get,
at that
the 1
distance,
degree change.
then Polaris has to be however many light years away.
Yeah, well, you could actually do the math and specifically calculate how far away it is. But
yeah, but what I'm saying is it's in a decided place.
For the purposes of measuring 1 degree, it really doesn't matter if it's 1,000,000 miles away or 1,000 light years away. All right. The fact is that this doesn't match reality.
You just said that?
Yeah, no, it really doesn't matter because
miles away? It surely would.
It really doesn't for the observation of Polaris being in alignment with our axis of rotation. All right. The fact is that this is the thing that we observe in reality and matches predictions, but this simply does not. The observation of 1 degree every 69 miles doesn't work if the Earth is flat.
How do you know it does not work?
Because the maths doesn't work. For every 69 miles, it would not be a 1 degree change. It would be more than 1 degree.
No, but it is a 1 degree change.
It's not. It's more. It would be more. It would be a different amount each time.
I'm saying on the real Earth, we make.
Yeah, on Earth it is. That's right. On Earth, on Earth it is 1 degree, right? Yeah. But that observation.
So you're going to try to
wait. That observation and that prediction is exclusive to the globe. It does not work if the Earth is flat.
Let's show
69 miles would be. Well, the math shows it. 69 miles would not be a 1 degree change. Every 69 miles, it would get.
So how far is the Polaris in the sky on the flat Earth then? You're deciding how far away this star is.
It really doesn't matter how far away it is.
Oh, come on, Craig.
No, it really doesn't matter.
So it's 10 feet in the air, let's say.
Well, we know it's not 10 feet in the air because
Okay, it's a mile. It's 10 miles in the air, or it's 20. It's 100 miles in the air.
We've been higher than that.
200 miles.
We know it's not there.
I know. That's what I'm saying though. Is it matters how high it is?
Yeah, but right. So it can be on the flat Earth. It could be 500 miles. It can be 1,000 miles. It doesn't matter. The maths on a flat Earth, every 69 miles, it would not be a 1 degree. Yeah, it doesn't work. It simply does not work. 69 miles does not equal 1 degree if we are on a flat plane.
Well, that's like saying that you can't have two celestial axes of rotation on a flat Earth. That you can't say that. It's not connected to the Earth. It doesn't even have anything to do with the Earth.
Well, you need to come up with an explanation as to why that happens. The globe Earth has a hypothesis and predictions that make sense for having 2 axes of rotation in the sky. And there's no explanation for that on the flat Earth other than, the sky's moving. No, there's not.
Sky.
Yeah, exactly. The sky is moving. Why is the sky moving?
I don't know why it's moving. I'm just saying it is.
Well, you can't.
We clearly see it.
But when you follow science, the observation doesn't match reality.
So,
all right, this is what's
on my screen right now of the stars turning. That doesn't match reality. That is reality, Craig.
No, it doesn't match reality when you follow science, because what you do, Joe, is you do pseudoscience because you go observation. That's it. I'm done. Looks like the sky's turning. Well, obviously the sky's turning. Anything that goes against that is going against what we observe. But that's not how you do science. You make an observation. Wait, hold on. You make an observation, then you do the science. You do a hypothesis, a prediction, an experiment, analyze your results. If you don't do that, it's pseudoscience.
Okay, so pseudoscience is what you're calling it, and that's fine. What I'm doing is, okay, we could call it what's on my screen, the star trails right there. Okay, we can call that a test. That's a test, because what I did was I set it's a exclusive, not talking about a globe or flat or whatever, but I'm saying it's exclusive to know whether the sky is moving or the ground is moving, because my camera took a time lapse and I did not move my camera.
Yeah, but your
So-
camera's on something that's moving, so...
No, you say that.
Well, yeah, we
don't
know it's that
we don't
because
know
it's been
that.
measured. We do. That's why we do the tests. Right?
But the test that I'm doing on my screen right now showed me that the camera
But
never moved
that
and
is
the sky was.
it's not something that's exclusive to a flat Earth, because what you're showing there is what we expect to see if the Earth is a globe.
And I don't think that it has to be exclusive to either one.
It does.
It's
That's
just
how you do
an-
science.
It's just an observation. It's
Well,
just
yeah,
an
but
observation.
okay, so then it means nothing if it's just an observation.
Well, it means something because that's the
No,
only
not-
way
not
that
unless you
perceive
follow up
anything
this-
is by observing it, right?
Yeah, but we don't base reality on what we observe. That's not how it works. That is literally pseudoscience, and I don't do pseudoscience.
So reality isn't what you experience, and what that's
No,
kind of what you're saying.
Our
You're saying, well, it
senses,
looks
our
like the
senses
stars
are not good enough
going
to
around in a
determine
circle, but they're really
reality.
not.
No, they're not. They're not. That's what it may look like, right? But then we do science to determine if that is true. And science
But because
says
it
it's not
looks
true.
that way, that means it is that way.
No,
like
that's
like
pseudoscience.
what I'm saying is, I can tell you, Craig, that right now, whatever star is zenith above your house right now, that in 12 hours or 4 hours, it's not going to be the same. It's going to have
Based
moved.
on a globe
the
model,
sky
yes.
will have moved.
Yeah, but that's what we expect to happen if the Earth is a globe.
Yeah, and that's fine. That's fine.
Right. So nothing you say is exclusive to flat Earth. That's the thing. All
don't
you're
think it
doing is
has to
going.
be.
It does for
I don't think
science.
has
It
to be
does.
exclusive.
No. For science,
You're
it
saying that-
absolutely 100% does. You cannot do an experiment to test something if that experiment could have two possible outcomes. You're looking for
Okay,
one
so I
outcome
did
with
an
your experiment.
or a test with my camera, and I put it on time lapse.
Yeah, but then you
and the
saw what
result
we
is on
expect
the
to see on a
screen
globe.
here.
Yeah, and
So
but you
my
didn't
test
get an
showed
result
me-
what was that
showed
was
me
exclusive to the flat
that
Earth.
the Earth wasn't moving because
No, it
my
didn't.
camera was not moving on the Earth.
No, it
And
didn't.
I understand. No, you have a concept or an intellectual idea.
No,
that
we don't.
that's
We have
because the Earth is
science. We have science. You can't just go. It looks like because my camera was still, that the sky is rotating. Therefore, that's what we're going with. That's not how you
Well,
do science.
But the sky is literally rotating.
No, it
you
looks
could-
like it's rotating.
It gets exactly. We experience it rotating,
Yeah. Okay.
Well,
So now we need to test that.
and I just. So I
No, you-
how,
no, you
how do
didn't.
we
You-
test that? How do we test that?
My test works. My test works to say if it's actually the sky or us. Because my test was something that is exclusive to the globe. It
And
can
what was your
only the 6-9 miles away for 1 degree, all right? That is something that is exclusive to the globe. It can only happen if the Earth is a globe. It cannot
I don't
happen
agree with
if
that.
the
I
Earth.
don't agree with that at all.
The wonderful thing about science, Joe, is it doesn't matter if you agree with it or not. It's still right.
So if science is right, and it says that what's on my screen right now that appears to be moving, and that I have tracking motors on my telescope because it appears to be moving. It only looks like it's moving.
Yeah,
But
the
all
camera is
reality-
on something
let-
that is moving. The
give me a second.
camera
Give me a second.
itself is on something that is moving.
That's a theory that you have.
No, it's not. It's not a theory. It's something that has been experimentally verified.
Okay, so even if, let's say that the camera's on something that's moving, but where the camera is, that's where we live. Okay. So if it's on something moving and the sky's like that because of that, then the sky is not moving, right? And that's because of Earth's rotation. 21
Yeah. So we need to be able to test if the Earth is rotating or not. All right. How do you test if the Earth is rotating or not?
I don't really need to test it.
Yeah, you
We
do.
can. Well, I don't think so because
No, it doesn't matter. Doesn't matter what
right
you
now-
think, Joe. No, you can't just make assumptions and go, "That's what it is." You need to test and show this thing, right? What you have shown, what's on your screen, right, gives us two hypotheses. Okay, we can get two easy hypotheses from that. Either the Earth is stationary and the sky is moving, or the sky is stationary and the Earth is moving. So we need to test
Yeah,
for
I can agree
one of
with
those
that.
two things, right? How do you test to determine which one's moving?
Well, I think a good test would be to put my camera outside
Nope,
on
that can't test
the
to
part
see
that
if
I
the Earth is
experienced
rotating.
that's not moving.
No,
See, here's
that's
the
not.
difference,
That's
Craig.
not how
Let-
you
let
test.
me-
Wait, no, that's not how you test if the Earth is rotating by putting a camera on it, because the camera will be on the thing that is rotating, so it won't be able to show you that. How do you measure?
But I don't
how do
start
you
there.
act?
I don't start with the Earth rotating.
No one's starting with the
start
Earth
there.
rotating.
Well,
We're testing the hypothesis.
So how else do you test? How are you going to test? So you're saying you have to test it from another place that's not the Earth. You have to test it from
No.
somewhere else.
No, you can test if the Earth's rotating on the Earth. It's quite easy.
Okay. How about if then we can also test if the Earth's not rotating on the Earth, right?
Exactly. Should we watch a test for that?
If the Earth is spinning at one rotation every 24 hours, that means that every hour
That's
has
light.
to turn 15
That isn't
degrees.
the Earth
Shh,
itself.
wait.
The
Wait.
gyroscope is
Well,
mounted
That's light.
anywhere on Earth, it's going to drift. In today's 21st century navigation systems, they're using what's called a ring laser gyroscope. It is extremely precise. If we could simply get one of these ring laser gyroscopes, we would be able to prove once and for all that there is no rotation to the Earth. One of the people in the community actually purchased one for $20,000. But what we found is when we turned on that gyroscope, we found that we were picking up
Everybody all together, a
15
15 degree per hour drift. It's not just
the Earth
light,
is
right?
spinning-
You're not testing light. You're using equipment designed specifically for a job to do a test. That's what
And
science
you're
is.
using light in that test. You're using light.
Yeah, correct. And that is
ring
a perfect
laser gyroscope, right?
That is a perfect way of testing whether the Earth is rotating or not, because that can tell us if the ring laser gyroscope is on something that is moving. If the ring laser gyroscope,
how do you know? How do you
if the
know
ring,
that
if the ring laser gyroscope is on something that is moving, it will show us that, and it does.
And it does. Okay. Thanks, Bob.
Thanks,
here's,
Bob, indeed.
Here's the thing. I don't think that the ring laser gyroscope is measuring the ground that it's sitting on.
Doesn't
It's
matter what you
measuring
think.
something else.
What's it measuring?
It's measuring the sky. It's measuring.
can't do that.
It's measuring
It can't
something
see-
that we
it
don't
can't
know
see
how
the
to
sky.
detect.
It can't see the sky.
Well, what I'm saying is that anything that's getting a drift is just so happens to be getting the same drift as these stars moving.
So you're just making something
in the
up with
picture.
no way of, you're going, oh, well, I don't like
No.
that explanation, so I'm going to make up something to explain it.
No, I don't think.
No,
I don't
that's
think
simply not,
apparatus
that's
made by
simply
you is
not
good
how
enough to
a
test
ring
it.
laser gyroscope works. It's the physics of how a ring laser gyroscope works says that what you are saying now is complete and utter bullshit.
Except that it's measuring the movement literally of laser light.
No, it's not.
A ring
That's
laser
not-
gyroscope. What
it's
does
not-
it send?
it-
What does it send out that races around that tells you your different position? What does it send
Do
out?
you,
A laser?
do you,
Is
do
it
you
light?
know how? Yeah. Do you know how it measures what it's doing?
Yes, I do. I specifically do. What I'm
Okay,
saying
please,
is it's
please
measure-
explain
it's
to
a-
me.
it's
Please
a
explain to me
measurement of
exactly.
light
Please,
hitting
wait.
a
No,
sensor.
please explain to me exactly how a ring laser gyroscope measures the rotation of the Earth.
It'll send two signals or two whatever lasers out in different directions around the inside perimeter of a container, and
Not
they'll
really, no.
the equal distance from them on the other side is a mirror or a sensor, I guess. And this is general. I'm not saying I have one or something. And it will shoot out the two lasers at the same time. And if you are turning that container, the sensor on the other side is going to receive the laser before or after the other half.
I mean, that's so wrong.
It's exactly what it is, Craig. It's
No,
exactly
right,
what it is. That's how
let me,
it works.
let me. It's really not. Let me
If the
explain.
Earth is
Explain.
spinning
Oh,
at
no,
one
wrong one. Go away,
Okay.
Bob. Let me explain to you,
You explain
how it works, because that was very, very wrong. Let me just get the screen up 1 second. Okay, so this is an explanation of the Sagnac effect, which is how a ring laser gyroscope works. So this blue box will fire one beam of light or laser,
And it'll
right?
split it. Okay, it'll split.
This mirror is half coated with silver, which makes half of the beam go this way and half of the beam go this way. Now, if when this laser is fired and it's split here, and this entire instrument is not moving, when the laser comes back to here and recombines, this sensor will be able to detect an interference in the light if the light has traveled a different path. Right now, that's if it's
wave, like a weird
that's
wave
if it's not moving. So as we see here, right, it's not moving. Both the paths are the same distance because it's not moving. So when
this
the light
is exactly
recombines,
what I was saying, except I didn't have it returning. I just had it going through.
As both came back at the same point there, you won't see an interference pattern. However, if it's on something that's rotating, as we can see here, in this one, it basically, because it's rotating clockwise, it's making the path that the blue laser has to travel further, which means that when it gets back to this point, because the lasers have arrived at different times, the waveforms will be different and it will register as an interference pattern. That can only happen, it can only happen if the entire instrumentation is rotating. That's the only way that can happen. There is nothing else that can cause that to happen. The reason that there's nothing else that can cause that to happen is because light...
How do you know that light
hold on.
Doesn't
light,
move?
Let me explain. The reason we know that this is happening the way we say it is because light doesn't have a charge, right? Light has zero charge, which means that it will not be affected by outside electromagnetic interferences of any kind. No ether,
light has
no looking at the
degree per hour drift.
It doesn't. We know that.
All the lights that we have in the sky do.
No, they don't.
Yeah, they do. They all move 15 degrees per hour.
The moon would disagree with you.
Who?
The moon.
Who would? You would?
The moon would disagree with you.
Oh, what is it? 14.8?
No, it's nothing like that.
Okay, how many? What? You gotta be kidding me, Craig.
Now
you're saying that the moon doesn't move 15 degrees per hour?
No.
Okay, tell me how fast it moves in degrees per hour.
I think you need to look. Oh my god. Anyway, so this cannot see what is happening in the sky. There is nothing in the sky that could make this happen. Okay, and you can actually confirm that this is happening in one simple way, right? And it's actually something Bob did, and that is to rotate it the opposite direction to what you think the Earth is rotating. If you rotate this in the opposite direction at 15 degrees to what the Earth is rotating, you once again do not get an interference pattern. Which shows that it is the rotation of the object that is causing the interference pattern and no outside
speed. What are we learning here? What are we learning?
Sorry, I'm just looking up.
360 degrees
24
in 24 hours
degrees,
is about 15 degrees per hour. So I would have to say that the moon's moving about 15 degrees per hour. Maybe I'm wrong. I think every light in the sky is moving at 15 degrees per hour.
No, not everything in the sky moves at 15 degrees per hour. It's as simple as that, right? Not everything moves at 15 degrees per hour. The things that we expect to move at 15 degrees per hour do, but not everything does.
What is moving in the sky that doesn't? Now I'm not talking about like the ISS, but what lights in the sky aren't moving at 15 degrees per hour?
Satellites?
No, I'm saying not man-made things. I'm saying of nature or whatever.
Oh, sorry.
All the stars, the sun, the moon.
Hold
planets,
on, my stream.
About that speed.
One sec. My stream is buffering. One sec. I think the stream's back. Sorry, guys. Didn't even notice that my stream had dropped there. Yeah.
I had just
planets.
time.
Other planets like in the sky, they don't move at 15 degrees per hour. Galaxies like Andromeda don't move at 15 degrees per hour.
Well, how fast do they move? How fast?
I don't know.
Is it
I don't know exactly.
0.002 or what? But like how many degrees are you talking?
I don't know exactly, but not everything moves at 15 degrees per hour. We can,
Okay, so
planets,
at night when
planets, meteors, comets.
Craig, I think what you're
all
doing
these
is
things.
you're trying to say something that you don't know, or you're trying to act like you know something you don't know, and I'm not trying to accuse you of that. I'm saying
No,
that
I'm not. I'm just
when I
saying that
have my
not
telescope
everything
out
moves at
and I'm
15. Not,
tracking
not
anything in
everything
the
moves
sky.
at 15 degrees. You know, planets, the moon, meteors, comets, all these things. Retrograde motion of planets in the sky. You know, all these
they
things.
still move
there's
about 15 degrees per hour.
They can if there's retrograde motion. That they literally can't move at 15 degrees per hour.
Okay, so do they come up the next night? Does it the planets?
No,
the Jupiter.
No, the planets
time?
aren't always in the same place. No, and meteors don't move at 15 degrees per hour.
And I'm not talking about meteors. I'm talking about the lights in the sky that are always there: sun, moon, and stars, and planets, or whatever.
Yeah. So
if they don't show, if they're not moving, if they're moving a different speed than 15 degrees per hour, then they can't show up real close to the same time next day.
Yeah, and
okay?
well, the moon, I think.
Obviously, it's a different time because the constellations move throughout the year, but almost the same time. Now, like the moon gets lapped by the sun like almost an hour each day.
Yeah, but the point is, not everything in the sky moves at 15 degrees per hour. There's many things in the sky that don't. All right.
Okay.
So we can't say that all of the light in the sky moves at 15 degrees per hour because it doesn't. It simply does
the sun,
not.
Moon, and stars. I'm saying the fixed lights.
Yeah, but that's not all right. So you've got to be specific, and but that's not how it works. It's simply not how it works. The Earth rotates at 15 degrees per hour. That's what that shows. But there's other ways that we can tell the Earth rotates at 15 degrees per hour, right? And that's using a fucking pendulum. I've shown you the pendulum experiment before, done by the gentleman physicist.
Yeah,
that's another prediction.
Because it acts this way, that must be a globe. That doesn't.
And that's science. That's science. All right, you make a prediction, test the prediction, and the prediction is true. That's
then
what
it can only be that.
Until there is an alternative
Else,
explanation.
right?
It doesn't matter. If science figures out something else, that's great. But at the moment, that's the explanation we have. You can't just say it might be something else without providing a hypothesis and an experiment and stuff. All right.
Well, what I'm saying is that's kind of closed-minded. That's not science.
No, it's not closed-minded at all.
This is what it
science.
is. We know it.
But that's the thing.
No,
we don't say it's over. We don't say it's over. You're totally misinterpreting what I'm saying. That is what we go with. If that's what the experiment shows. However, science is never complete. We never say we 100% say that's what it is because we might do an experiment in the future that disproves what we've said. However, at the moment, the explanation that science suggests is that the Earth is rotating at 15 degrees per hour, and there is nothing at all ever anywhere to suggest that that is incorrect.
Well, I think that there are, but
no, there isn't.
So
there simply isn't.
If the sun's moving at 15 degrees per hour, and if the sun basically each day, I don't know what is it, 50 minutes or something, that the moon comes up later each day to go as it goes through its phases. I think it's like 27.3 or 7 days or something like that. There's a new moon.
Yeah.
So how many degrees are we talking? We're talking 14.9 degrees. Or what I'm trying to make a point is that to say that the sun, moon, and stars aren't moving 15 degrees per hour.
Not everything in the sky is. It's simply not everything in the sky is. And observation, Joe, what aren't you getting? That what we observe. Okay, great. First part of science. Then you do the rest. All right. To not do the rest.
Against that observation, and that must.
It doesn't matter. It doesn't matter if you go against it or not. Science says that your hypothesis can be whatever the fuck you want it to be, as long as it's testable. All right. Your observation is just the start. It is just the start.
There's a lot of things you can't test, like as
what?
far as like bending space time.
Again, that's been tested.
An experiment in 1919, but
and the Pound-Repka experiments as well. There's lots of experiments.
How would we go about doing that? I'm not familiar with those experiments.
Well, you'd have to look up the Pound-Repka. The Pound-Repka experiments is about testing how much energy light loses as it travels away from the surface of the Earth. It confirms the predictions of Einstein. The The experiments, I think, were done on a massive tower in France, and they fired lights in the bottom and shot them up, and basically measured the redshift as they travelled away from the Earth to see the gravitational potential, matching the predictions of Einstein. It's redshift due to gravity, basically, which matches what Einstein says about space-time. So it's all been tested, right? Space-time bending has been experimented on and verified, with nothing to disprove what has been verified ever. What
is the cause of this gravity, or whatever you want to call it, the bending of space? What is the cause of it?
Mass.
Well, what causes the mass to have those properties, or to attract other mass, or whatever?
The fact that it warps space-time, and anything traveling in a straight path has to travel through that warped space-time.
Okay, why is it that? What I'm saying is, what is the cause of that? What's the mechanism that I think we call it gravity, right? What is that? I'm saying what force is that, or whatever? What makes that happen?
I just told you
what's predictable.
The mass of an object warps space-time. Okay, it puts pressure on space-time and warps the very fabric of space-time. Okay. And that's something
I don't
that
see any fabric
is
myself,
testable.
but
the fabric of the universe is something that can be manipulated and warped, showing that it's not just nothing. Time dilation shows this, for instance.
See, I'm seeing a place of darkness in the sky that is a place that if you go there in a specific way, you will
matching the physics and the predictions of a globe Earth. Yes.
Sure, whatever. Or if you just go there. I'm saying that all of these things don't really have much to do with a globe or flat Earth as far as what is really going on in the sky. What I'm saying is that
orbits don't work if the Earth is flat.
Well, I don't think that that's true either. I think orbits...
It absolutely is true. You can't have something orbiting a flat Earth. That's called going round in a circle, not orbiting.
It would be a circle, yeah. It would be a circle. And what I'm saying is the place up there, everything that we know of, every person that's ever gone there, every vehicle we've ever sent there, every probe we've ever put up there, whatever, has all experienced the same free-falling properties. Like when MECO happens, when the main engine shut-off happens, that's when you can experience this place. Until then, you're under G's. You know what I'm saying?
Yeah, matching the predictions of the globe. Everything you're saying is what we expect on the globe.
Forget about matching the prediction of the globe. I'm not really necessarily talking about that. I'm just saying the sky.
It all comes down to that.
There's a place of darkness in the sky. And I don't see it as a big universe myself. I see it as almost like a pit, like a tube of darkness. And
a tube of darkness.
Yeah, where everything is falling.
Are you just making stuff up now?
No, it's just it's what they experience when they go up there. Free falling in darkness.
They experience a tube of darkness.
A tube, not a cube.
Yeah, it said tube.
Like a tube.
I don't think I've ever heard.
The reason why I say it's like a tube is because when they.
But I don't think I've never ever heard an astronaut describe space as a tube of blackness.
I don't really think that it's actually a false statement to say that, because what do we experience when we go there? Free fall.
Yeah, matching what we expect on the globe with gravity, with no explanations in the flat Earth.
No, there is an explanation in the flat Earth. That's what I'm saying.
No, it's not.
It's a celestial place. The sun and moon. Like when Einstein was looking.
One sec.
Einstein?
I'm bringing in Tony, PhD Tony, who's a PhD
Tony. I'm just kidding.
Yeah. Maybe he can explain some things to you.
Okay. I know Tony don't like me very much, but I like Tony. He's a nice guy. But I think that this is something. I'm not saying you have to look at it this way, but that NASA will tell you that if they put something up there and they move at that orbital velocity, that they experience essentially 0G inside of their spacecraft. And that's the only way to stay up there. That's what I'm saying, is the only way to stay up there is if you are doing this specific type of sideways motion and you go a specific speed or faster.
Okay, all right, let me introduce Tony. All right, Tony, hello, thank you for joining.
Hey, Tony.
No problem. Hello, F-Tup, or do you prefer Joe?
Joe's fine after whatever works.
Yeah, okay.
Tony, my head hurts. Please help.
I'm slowly giving him a concussion.
Yeah, okay. So let's look at a few things. Not everything rotates at exactly the same rate, right?
Yeah.
When viewed from Earth, even the stars that you are describing as fixed exhibit, or the objects that you say, they vary in their position relative to one another, right? So in the course of one solar year, the stars actually do one less rotation than so there are 365.24 solar days in a year, but there's about 364.24, if I'm remember. I think that's the way it works. There's one less sidereal day in a solar year. So the stars are not rotating at the same distance as the sun, at the same rate as the sun, and you can also detect angular deviations in the positions of nearby stars, which is called parallax, right? If you take observations that are 6 months apart, you can see that the stars are in slightly different positions. There are also things called proper motions, which are stars that actually exhibit a motion relative to the other objects that is not due to parallax.
That's like retrograde? Is that
no, retrograde motion is because Earth is orbiting, right, and we're looking at Mars, say, that is orbiting. As we hit sort of the edge of the disk and then turn back and go in the other way, the direction that Mars seems to go in the sky is opposite, and the same happens when Mars hits the edge of it. So that's retrograde motion.
Is that something that's just apparent? Sorry, I'm not trying to cut you off.
No. That's exactly what it is. It's just apparent. So it's
okay.
It's one of the things that sort of early astronomers noticed about the planets that made them, different, because they didn't. Yeah. So it's and they had to come up with these explanations, and they tried explaining it in terms of circles, and they weren't actually able to do it, which is why it took sort of the understanding of elliptical orbits to really understand what was going on there. So you're right in this, and you kind of self-fulfilling a little bit when you say, well, it's only the fixed stars that move at 15 degrees an hour. So it's the objects that move at 15 degrees an hour that move at 15 degrees an hour. Yeah, that's kind of circular. But, as objects move closer to Earth, comets and that sort of thing, we can see very significant deviations in their apparent angular motion. As comets move around the sun, we can see that the angle that their tail is at relative to Earth, if the Earth and the comet are over here and the sun's over there, then the tail of the comet points that way, and it's very, very long. But if the comet's over there, then the tail still points away from the sun, but we don't see it, and so the angular size of the angular size of the tail varies, and it varies according to angle from the sun, right? So there's a lot of, if you look closely at sort of celestial objects, you'll notice that people would come up with people came up with very simple, direct explanations, and it turns out that those direct explanations couldn't explain what they were observing in the night sky. So they gradually had to come up with more sophisticated explanations.
And then with space exploration, it's advanced that type of knowledge.
Yes,
or
that's
type
right.
verification, or you right? Is it?
Yeah, okay. That's right. And you asked an extremely profound question earlier. Why does mass bend space-time? And the reality is that we don't know why mass bends space-time. That's just the way it is.
Okay.
And many people will say, well, if you don't know that, then you don't know anything. Well, I mean, that's being intellectually dishonest, right? I mean, we hundreds of years ago, we didn't know a lot of the stuff that we know now, but we worked it out, and we've developed a lot of technology, and we've improved a lot of the average human. We've increased life expectancies. We're able to treat diseases and better understand. Everything's moving in the right direction. And we do this because even though there's stuff we don't know, there's less stuff that we don't know. We're slowly moving forward. We're progressing.
Learning.
And that's we're learning. And that's one of the problems. That's one of the problems that I think the Flat Earth movement has, is that in order for it to be true, we have to unlearn a lot of stuff. We have to suddenly not know what. I talk to a flat earther. He doesn't know what Mercury or Venus are. Doesn't know what Mars is. Doesn't know why Jupiter appears to have moons. Doesn't know how gravimetric gradiometry works. Doesn't know how gravimetric mineral exploration works. Doesn't know how GPS works. So there's a lot of all of this stuff that we developed. We developed this technology. We developed GPS satellites because we well understand how things work, and we worked out that there were very useful scientific applications for it, and sort of you have to unlearn that. You have to go suddenly, well, that works, but now we just don't know why it works, and we've got to make up some new physics to explain why it works. Well,
I can understand where you're coming from.
Yeah.
Can I ask you a question?
Yep.
In your opinion, like the knowledge that we're gaining or we're learning, and the things that we're learning, like our technology and just the knowledge that we have about things, how much of that do you think has been increased because of space exploration, going to space?
I think that we've learned, certainly we've developed a lot of technologies as a result of, efforts to get into space. We've,
Yes.
there was a massive push for, smaller technology, lighter technology, more robust technology. And I mean, this is one of the things that a lot of,
is like
we're
continually.
Yeah, that's right. And I mean, so historically there may have been other problems that we would have wanted to solve, that we would have developed this technology for, but in this world space exploration played a huge part in answering a lot of our scientific questions,
Especially about the model or the globe, the or the solar system. That I know that people were looking at that a long time before. But
yeah, they were,
and they were actually debating it. They were debating these things for, I think, all throughout time, basically.
Yep. And I mean, this is something that is often misunderstood about. This is often something that's misunderstood about the nature of science, is that there are always people who are going against the current narrative. You will have heard, for instance, about plate tectonics. That's and plate tectonics was widely reviled. It was attacked ruthlessly when it was introduced as an idea. But over the course of about 10, 15 years, the evidence that was produced made everybody, even every rational scientist at the beginning of the 1950s would have, every reputable scientist would have shot down any attempt to suggest that, plate tectonics, that the continents move. It was completely rejected. But over the course of the next 15 years, the evidence that was presented was sufficient to overcome that. But even though plate tectonics is successful, there still exist people who don't believe it. There still exists a tiny proportion of people, and
they were
to be honest, who are against it. And that's the way, that's pretty much the way with any social group, right? You'll always have these people who don't want to toe the line, who don't want to conform. And quite frankly, a lot of the people arguing against plate tectonics are actually kind of crackpotty. You know, there's
Tinfoil
expanding
hats.
Earth. Yeah,
Just kidding.
they call it expanding Earth theory. So you know that their argument is that everything's getting bigger. The Earth is getting bigger. It's expanding, and that's why these plates are moving. Got nothing
That
to
R
do with
value's going up.
Yeah, the R value is going up. That's
Okay.
exactly what they're suggesting, and it's but that's the nature of science. You know, we're constantly prodding and probing, and actually, you know, I want to say to some extent that I, for one, am a little bit grateful to flat earthers because there was a lot of stuff that I myself didn't really understand, and
Like
so
the
the couple of
depth
flat
of
earthers.
certain things.
Yeah, well, yeah, how we know, you know, and sort of, I had to step back and relearn some high school physics, right, that I'd forgotten.
Yeah,
you kind
I'll
of
second
learn,
that,
you know,
Tony.
there's stuff.
I've definitely had to kind of relearn some of the things specific to the things we're talking about, you know, because you when you're studying physics, it's such a general thing. You study so much that you never thought that you'd focus on things specific to debunking a flat Earth. So I think all of us, you know, getting into this have had to brush up on specific areas, right?
I can't. I don't think of it normally from that point of view, or you know, from where we're looking at it right now. But I can say that I totally agree that this is a beneficial debate, or whatever you want to call it, for everyone. I think that, I think whether or not it changes your beliefs or not, I think it's important as far as a learning experience that because I know things, I've learned things that I never would have even thought about if I hadn't been in these debates, you know.
And I think that's why you're a recurring guest on Fight the Flat Earth's channel, is because you used several key words there. One is debate and the other one is learning. So, you know, you have to be willing to acquire new knowledge, to learn stuff and accept, well, this, you know, I thought this way, that turns out to be wrong, and now I'm going to look at things this way. That's a key process. And you used another key word, belief. Science is not really about belief, and it's not actually about knowledge per se. From my perspective, the more important aspect of science is understanding, right? It's not so much what you know as what you can understand. You know, I don't know what the escape velocity of Earth is, but I understand how to calculate it. I know exactly how to, you know, I know the numbers to put together in that formula to work out what the escape velocity is. I don't need to know that number because I understand how to get that number. So I think that it's, you know, a lot of flat earthers seem to come into this, and indeed a lot of globe earthers come into this just believing, just knowing, without understanding. And I think we could all profit from increasing our understanding of what's going on. And if we do that, then we'll get to a solution. But you're actually a bit of an outlier as far as flat earthers are concerned, because although, you know, you're quite attached to the concept of flat Earth, you do actually learn in the process of these discussions, and that's, you know,
and Tony, I gotta say, you accused me. I think you were on Schrodinger's cat's channel, and you were accusing me of not listening to you during our debate, or during that talk we had before.
Well,
and I for sure listened. I was listening about the project. You didn't. You cut me a little bit short there. I was listening about the satellites that you were talking about, and their different positions and how far they were from each other, and like I was understanding that. I was listening. So
well, you just seemed to come back the very next day. Like, I had this conversation with you, and then the very next day you were back, you know, saying some things, and I thought, oh, you know, perhaps he ought to be a bit more cautious about what he's saying.
That's kind of how I feel.
Yeah,
we'll have conversations with UF.World, and then, you know, the next day you're posting the same dumb stuff on Facebook, and it's like, have you listened and actually taken in anything that we've tried to explain to you?
I feel the same way about you guys, and I'm not saying it in a negative way. I'm saying that some of these things that I'm bringing up are not big differences. They're not big changes. What I'm saying is, like, about there's a reason why I really consider it to be an important observation that we make of the sky turning. That, like, because of an understanding that I have about that place. And
Yeah,
and
but you
of
don't
course
have an
this gets
understanding.
into like the Bible and stuff too. But and I know that this isn't really the platform for that. But you know what I'm saying. Sorry, Tony. Go ahead. I was cutting you off.
Yeah. So if I wanted to prove that the Earth was spheroidal, I would absolutely not invoke stars or celestial objects or the sun.
I
Right?
agree.
I would reject all of that evidence uh, because you can explain a lot of it away with some funky physics. But what I would look at is the properties of the Earth. Okay, and in particular, the properties of earthquakes traveling through Earth. So,
Oh
you
yeah,
know,
you were saying how the echo or whatever from that
yeah,
goes all over the surface of the Earth.
yeah, and it does multiple laps, right? And it does it in a way now. So, you know, let me just get a prop because I did. Prop is perhaps overselling it, but I'll be back in a moment.
Nice shirt. I think I saw conspiracy cats on there.
Yes, just while he's grabbing that prop, just a reminder to Pro Tosser that you are more than welcome to come and spread your stupidity. I mean, debate me about your batshit crazy views. But we all know that you are too scared, and just going, you're not going to bait me by saying I'm too scared, doesn't change the fact that you are too scared. So I'm just going to take it as a default win because you're far too afraid to come and even talk to me. So winner, winner, chicken dinner.
Winner, chicken dinner.
Yeah. Well, that's the level of maturity that people like that deserve. Yes. But yes, I think I'm a huge fan of Conspiracy Cats because I think that he is one of the most remarkable science communicators
He's amazing.
I've ever met, and
One
a
of my
good guy.
favorites of his is the 4-foot level phone that Leonard Millionaire. I can't stop laughing every time I see that. I'm like, no.
Every time he does that, it's
how
again,
do you come
it's
up with that
kind
stuff?
of
That's
childish.
so creative.
It is so creative. It's kind of childish again, but
no, but that's part of the fun.
Conspiracy Cats is the master of being childish without being childish. I love it.
Yeah. So here we have our image of what's going on, and so if we have an earthquake and we put it at the top here, it's going to send out what are called surface waves, and there are two. You know, if the earthquake is sufficiently big and close to the surface, it's going to send out what are called Rayleigh waves, and these travel out. And if we've got a seismic receiver over here, it'll see the wave going past, but it's also sending a wave out in the opposite direction. And so after a while, that wave is going to come up, and it's going to come up from the opposite direction. It's going to sneak up from behind our seismic station. And so we're going to get one Rayleigh wave going this way, and then another Rayleigh wave that's come around that way. But that isn't the end of the story, because this Rayleigh wave continues around and comes back back to the receiver.
If it's a strong enough quake.
If it's a strong enough quake, and this one comes around and goes up like that. Now, this is very much consistent with the idea of a vibration. And it doesn't matter where the receiver is. The first travel time is only dependent on the angular distance, angular separation from the earthquake, and then those return times are kind of fixed by that value. And it doesn't matter where the receiver is, we will receive those. And back at this, if we've got a receiver either side, we'll see this first one go around, but the second one, the one that's coming this way is followed very soon after by the one going that way. And so, we can tell, this is, like I say, this is very consistent with a spherical ball a spherical steel ball that has just been hit, and the vibrations roll down the ball and then roll back up and roll back down and roll back up. I've seen flat earthers try and explain this by claiming that the waves reflect, right? And so now we imagine that the earthquake is somewhere in the middle and the site's over here. But what happens is that the waves spread out in a circle, and then when they hit the edge here, something actually really weird happens in that they rebound as almost a straight line. So they would come, so
like
they,
almost
the
perpendicular to the surface, or
so it would be so you take the closest point on the edge, and from that edge they propagate back inwards as a straight line, right?
Okay.
And now, so we should be able to detect that, right? And the repeat time for the station, a station that is near the edge, will be a function of how close it is to the edge, not how close it is to the earthquake. How close is it to the edge? And so all of that. Actually, I am doing a presentation on this, so perhaps it might be easier if I actually bring that up. Would that be okay?
Yeah. Just so you know, the guy that you scared off last time, Mario, has joined the call.
Okay.
Hey.
Well, that's an unexpected bonus.
Yeah.
Okay. So let me.
Hey Mario, how you doing? Tony's explaining why you're a dumbass.
Okay. He's very quiet.
I know he is very quiet. He probably
Okay.
can't figure out how to use the audio.
Hello?
Hi,
Yeah,
Aaron. Hello.
Mario.
What's up with you?
Oh, so you've decided to come back? Well, after you ran away last time?
No, somebody had said something about me being a coward. I was saying, no, I ain't never no coward.
And why'd you run away last time then?
I don't waste my time either.
Oh, you're a flat earther, so you do.
Okay.
Nah. That's just like this. Hey, that's just like a Christian saying, "Oh, you're antichrist," because you know what I'm saying. Anybody can use that argument. You know, just because you got people behind you, it's a lot
I've got
of people
science behind
believe in
me.
Christianity. Hold up. It's a lot of people that are Christians and Muslims. Should I also say, oh, maybe I'm wrong just because it's billions of people who are Christians and Muslims? It's billions.
I mean, that's all relevant, but you know.
And they can't
Good
prove
point.
it.
It's a good point.
No,
It's a billion people believe Christ walked on water. So we got all, you know what I'm saying? If you can't prove stuff, I don't care how many people following you. You can call yourself a scientist.
Yeah, we
can
do
call
prove
yourself
stuff.
whatever
You
you
just
want
go
to.
nuh-uh. Mario, we do prove stuff. You just go nuh-uh.
I got a proof today that'll make you very uncomfortable. Both of y'all.
I'm sure it won't.
So I'm just going to share my screen. You've disabled screen sharing.
Oh, sorry. Yeah, Mario. Let Tony finish what he's saying, and then you can show us this new proof. Okay? Is that all right?
Okay. Can I?
Yeah, I'm just turning on screen share for you. There you go.
Yeah, I want to see the new proof that we have today.
Yeah, well, let Tony finish what he's saying, and then we'll get to see your new proof. That'd be awesome,
Okay,
all right?
yeah, I'd love to see something. What you got today? I'd love to refute something.
You should be able to screen share now, Tony.
Okay. So can you see that? Okay.
Yeah, I can see it.
So that pink star will be the source of the earthquake. That black cross is the receiver. The energy of the earthquake spreads out, passes the receiver, and then it's going to hit the edge and it's going to rebound. And as it rebounds, it's going to form a sort of a straight chord across the edge. It's not actually perfectly straight.
A straight what?
Chord. A chord is a straight line across a circle. Okay, it's a mathematical.
How do you get a straight line across a circle?
Like he's showing you on the screen.
Can you see your screen?
Yeah, I see it in your drawing. I'm talking about in real life. How do you get a straight line across a circle? Like, what is the straight line across the circle coming from?
So this is
sound
because
waves going every direction, not straight lines.
okay, so we can look at the. Let me stop that. Okay, and I can. So I stop that. Let me go back, and we can look at the an experiment regarding waves hitting a circular obstruction. Okay. So let's do that. So you made a claim that you're not going to get a straight line from a circular wave hitting the inside of a circular, it's not perfectly straight. I will admit that ahead of time, but it is pretty straight, and certainly straight enough over thousands of kilometers. So I just need to find the file and open it again. Okay, so let's go back to preview, and we can open that. But anyway, just give me a few minutes. You can talk amongst yourselves for a second.
Okay, well, while you're trying to find that, should we let Joe show us, tell us about the new proof that they've got?
Yes, sure.
Yeah, go on, Mario. Tell us about the proof that you've got.
The proof that I got? Oh, you want to see the new one today? I'm gonna
we'd love to.
Then. I'm gonna go on screen share real quick. Then I'm gonna go into my photos and grab one out.
This is going to be hilarious.
No, it's actually going to be very, very, very,
hilarious,
very damaging to the globe model.
I mean, I would bet my entire life savings that that's not true.
Okay.
If it's damaging to the globe model in any way, I will delete my channel.
Okay, buddy.
So come on, are you sharing?
Yeah. Hold up. Let me find a picture real quick. Okay, it's in my photo colleague maker. You see the picture?
Yeah.
Okay, so in this picture, what we have here is we have a rotation around the sun. And according to the globe model, they say that the sun is what gives the moon its light. So if that was true, the moon phases would flip in 6 months, as we see in this drawing, with the sun in the middle hitting both sides.
Oh my God.
Of the ball. And so if I look, let's say, if I see the shadow, basically I took these two screenshots. It's showing what the moon phase is gonna be in Michigan, exactly 6 months apart. So if we was flying around the sun, 6 months later, the sun's supposed to be striking the moon on the left side, not the right side again. In 2022, because we're on the opposite side of the sun. So we're supposed to be getting opposite moon phases. I would like to see a refute on that, or a graph on that, to show us why the moon phase is still on the same side after 6 months.
Quick question for you.
Can you show us a graph?
Yeah,
where they works on a
one
ball?
quick question for you, Mario.
On flat Earth, hold up, on flat Earth, the moon phase, the moon causes its own light, and it has an infinite cycle that the creator of the flat Earth put for every 29 days. It recycles itself. So can I see a refute of this?
Right, yeah, right. I've got one quick question.
Ball model where this works.
Dude, one quick question. Yeah, one quick question, Mario. Is space 2D or 3D?
No, this is how we would see it. We can't see both sides of this. Is the 3D.
Yeah. Again, is space 2D or is space Mario?
It's 2D already.
Mario, it's a simple question for you. Is space 2D? Mario, is space 2D or 3D?
Bro, the picture is 3D. It's just
no. That's a 2D picture in front of you. Is space 2D?
Image on a 2D picture?
Dude, it's a very simple question. Is space 3D? Just it's a
Go
simple
back to the
question.
Can you show us a ball
Yeah,
model where this works?
It's a very
move
simple
things on the
question. Can
same
you
side
just
after 6
answer the
months?
question, Mario? Is space 2D or is space 3D?
Space doesn't exist. What you talking about?
Okay.
In the heliocentric model,
Vacuum?
is space 3D or
Bro, show me
2D?
a
I'd like-
vacuum in nature. Can you show me a vacuum in nature?
There's no
Yes.
vacuum in space.
I
So-
don't see no vacuums in nature.
Yeah, no one says
Mario,
there's
how
a vacuum in
about
space.
if we
so-
said darkness? What if we said the darkness upon the face of the
Right.
deep? Does that
Right.
exist?
Should we let Tony respond to this image?
Hey, I see a
Okay,
deep
there.
ocean that hasn't been discovered, so maybe the face of the deep is real. We only.
All right, Mario. Mario, let Tony respond to your picture here.
Been 95% of the ocean, so maybe that. Maybe.
I
But
think the
don't
deep's
see
above us.
vacuums in
Oh,
nature,
okay,
though.
stop.
That's something that's
Right.
not even
Mario,
real.
stop. Right, let Tony respond because he was trying to say something.
Yeah, please.
Okay, I have multiple responses to this. A, you seem to have overlooked the fact that the moon is phase locked to Earth.
What they got to do with it, bro? Like this has no. I'm not talking about the face. As a matter of fact, like I said, if we on opposite sides of the sun,
Will
The
you
shadow will be on
shut up
opposite
long
side.
enough
Yeah,
to
right. Let
listen,
Tony
or
get
are you
let Tony
just
get a
going
full
to
explanation
practice?
out before you talk, Mario. Okay.
okay, my bad. I'm gonna let him finish. Go ahead, man.
Okay, the answer is that yes, we can do this with a ball model. And if you
Can I
grab
please? Can we see that?
Can you
Yeah,
let him
2D.
finish before you talk, please?
That was my first ask. I asked, can you show it? I don't want to sit here and talk about it. I want to see it because I don't
Yeah.
see that working in your model.
Okay, now be quiet and let Tony
Okay.
respond.
Now, do I have the graphics necessary to do that right here? No, I don't. I'm sure that somebody
The
somewhere
graphic
does,
in front of
but
you.
I don't. Your understanding of the graphics in front of you is incorrect.
Now you trying to call it. We can simply see that the sun is in the middle, so the shadow will be on different sides. That's literally the common sense.
This is
What you
3D,
mean,
you
my
retard.
understanding?
As because the moon is phase locked to the Earth,
Right.
the same face is looking at Earth, so that so for instance,
Yeah, but the sun is on
bottom,
a different side.
yes, but if you take the bottom right hand, quadrant from the right hand picture and compare it with the top left hand picture. On the left-hand side, you will see that you are viewing exactly the same thing, right?
No, we not. The picture on the bottom has the shadow on the same side. We're supposed to be on the opposite side. Come on, man. Why? It's literally like I'm arguing with Chin. That's why I left last time, bro. This is common sense. The shadow is supposed to be exactly how we see on the graph.
Can I ask?
Bro, I cannot argue about what is we arguing about.
Can I ask how intelligent you think you are? Right?
You said how smart I think I am?
Yeah.
Yes.
No, I go by reality. So basically,
That
if
wasn't
it's
the
not
question.
Reality, I don't consider
So
it.
if somebody with superior education and superior
There's no
intellectual
such thing
ability
as superior
tells
education.
you-
What is you talking about?
Yes, there is.
tells you that
What you
yes,
mean
there
superior
is.
education?
Are you a brain surgeon?
Hold up, so somebody know more 90s rock bands? Is they smarter than you? Just because they know more information?
They may be.
Can you name me every Ludacris album? Or I'm not. So you're not smarter than me. That irrelevant ass stupid information. I don't care about that.
Actually, there is a
Superior
difference
knowledge.
between.
No such thing as superior knowledge. Everybody gets the same information.
Yes,
It's true or it's false.
Yes, there is. No, there
No,
is
it's
such
not.
a thing as being. There
That's
is such a
refutable.
thing as being. Okay, then I suggest you go down to your nearest hospital and suggest that you should be installed as their chief brain surgeon because you know just as much about brain surgery as the person who's in there. No,
First
this
of all-
conversation is done now. You've presented your evidence. You're just flat out wrong. Now you can
No,
shut up
you haven't.
and you can let me get back to
presented
my
your model
conversation
that is works.
without tough.
You haven't presented a model that
conversation-
works.
this
Yeah, you just
conversation
blabbing
is
it out the
done now.
mouth, man. That's what I'm saying.
I can show you this in about 5 different modeling
Present
softwares if you
model,
want.
You're just flat
present
out-
a model where this works.
Yeah,
or
I
you're
can.
done.
Tell you what,
All
Mario,
Not
go
on
to
wings.
Mario. Listen,
right in front of
Mario, listen. Go to Stellarium and type in those dates. There's your model.
I just showed you the one. That's a very. I told you that was going to be an
Yeah, yeah.
uncomfortable.
Now
proof
go.
right
No,
there.
yeah. It's not a problem.
Now
Now
you
go.
can't present
Listen.
your model.
I've just told you where the model is.
Mario,
The shadow
the
should be on
fact
the
that
same
you are
side.
too
My
stupid and
The
ignorant,
shadow should be on
the
different
fact that
sides.
you are
It's
too
common
stupid
sense.
and ignorant to recognize the flaws in your argument does not make your argument valid.
That's not an argument. That's common sense. What are you talking about? There's
It's
nothing
not-
to argue about.
Okay.
Welcome, MC Toon.
Let's conduct a quick poll in the chat. How many people with university level, how many people in the chat have university level physics credentials and agree with Mario?
You don't have to agree
no.
with me. Present your model.
Yeah, I told you where the model is.
Hey,
The
show
model.
me a model where that
Yeah,
works.
Mario,
I don't care
listen.
if it's 2D,
Mario,
image, or 3D.
Mario, listen
Show
to
me
the
a model
words.
where that shadow
Mario,
gonna be on the same side.
Mario,
Mario,
listen
breathe
to
for
the
a second.
words.
Common sense. I'm like,
Mario,
that's retarded.
Mario, stop.
That's
Mario,
physically
breathe,
impossible.
breathe. Mario, stop. Right. 2 things.
Y'all
First of
arguing
all,
against literally physics. You're not arguing against me.
Mario,
The shadow's supposed to be on a different side. It's
Mario,
physics.
listen. Mario, listen. Listen.
Like, dude,
The
it's
model,
literally
Wait,
arguing
Mario,
against
You know
me.
physics?
Mario, the model you are looking for is
I know a lot
Stellarium.
about physics, man.
No, you don't know anything about
Self-education-
physics.
Hold up, let me tell y'all something. Self-education is the best education because there's no bias, no
that's
emotions
wrong.
attached. Just take
So-
the truth. What's true? What's
I
false?
say, go down to your local hospital and present that argument, or go to
I
an
don't want to
airport
be a brain
and say,
surgeon, bro. Like,
and go
what you
to an
talking about?
airport and say, I should be allowed to fly the planes
I know
because
stuff
I
the
am
brain
just as
surgeon don't know.
I am just
Hold up.
as
I know stuff the brain
Yes,
surgeon don't know. So
everybody
who is
knows
smarter?
something that other people
Oh,
don't know.
wait, Tony,
That
I
there's
know
doesn't
stuff the
make them
brain surgeon
omniscient.
don't know. History.
Tony, there's a better way. Tony,
History
maybe
is very special to know.
hold
It's
on,
one of
hold
my.
on, Mario.
Mario, stop talking.
I'm a
Mario,
very good historian.
Mario, stop
just a
talking.
second. If
So
self-taught
that's
is
how
the
I
best
know
way,
your literacy.
Mario,
Go
if
ahead.
self-taught is the best way, then don't you go and be the doctor when you next go
I
down
don't go
and
to the
you
doctor.
need.
Don't need to.
Yeah, just don't interrupt me here. The next time you do need to go to the doctor, because it might happen, maybe you'll break an arm or something while walking at night talking on the
Why
phone.
would I go to the doctor?
If you broke your arm, maybe, right? But then
Hold
what
up,
you
Find
should
your
do,
brain.
was
what
we
you should
doing
do,
about
Mario,
broken bones before doctors?
what you should do then, Mario, is you should say, no, I don't want the doctor that has been trained. I want the doctor that's self-trained how to fix arms. That's the guy you want.
Hold up. So
That's the guy you want.
So before
Or the
doctors,
pilot.
let me ask you this question. Before doctor, we were just walking around with broken bones, everybody dying from sicknesses.
May-
No.
Maybe that's what you prefer, but
No,
other
sir.
people
Your
don't.
history is false.
Okay, Mario. So let me just answer your question
This is-
quickly. The model,
Polio,
Mario.
measles, mumps,
Mario,
all
let me
that
answer your
come from
question.
vaccine.
Mario, let me answer. Mario,
COVID-19 can be found in nature. Vaccine. That's where it is. That's how you get it.
Mario.
Stop
I'm
with
trying
these
to.
fake diseases.
Mario, can you stop?
We never
Mario, take a
needed
breath.
doctors.
Fuck's sake,
We
shut
never
up.
needed schools. We never
Mario.
needed cops. We don't
Mario.
need judges.
Hello,
I'm having fun over
We
here.
don't need scientists.
Mario. Listen. Can I answer your question?
All
All
that
right.
shit is fake.
Oh
Just
my
like
God.
a mechanic wants you to
Mario,
break your car
I-
down.
Seriously, Mario, can you listen for just 1 sec?
Go ahead.
Yeah? Alright. The model that you keep asking for is on stellarium.org. That model matches the things that you say for the heliocentric. So that's your question
Now,
answered.
Screenshot, show us. Screenshot.
I don't have it downloaded right now. You can go and do it yourself.
Do your own homework. You know, actually, it's not our job to educate you, Mario.
Yeah, he
Go
wants to be
away
self-educated.
And do your own. Go away
Screenshot.
and do it
Well,
yourself.
prove me.
No.
I thought you wanted to prove
Can
me
you
wrong
mute
so bad.
him?
I showed
Can
you.
you mute him?
Prove my
Can you
model
mute
wrong
him?
right now.
Because he's
Screenshot
pointless.
it.
He's a waste of biomass. Why is he even here?
to laugh at, pretty much. Yeah, Mario, so just again, the model you are looking for is called Stellarium. So you can go and look at that yourself. It's got all the information on it. The model exists, therefore it's there. Okay.
Can you please screenshot it for me? I don't feel like doing all this.
I don't have it downloaded, so you have to go and download it yourself and look at it.
No, man, come on. Y'all just did a screenshot your turn.
No.
Yeah. I do not have it downloaded.
Actually,
you can go and download it
we-
yourself.
I know it's bullshit. That's why I don't want to go and look.
We
I know
would-
you ain't got it.
we
You would have
would-
brought that up.
we would-
You would have pulled it
we
up
would-
instantly to make me look stupid.
I
I'm
don't
not- I'm
have
not
it
following your-
downloaded.
Honestly,
I don't
I
wanna see that
see
shit.
no benefit. I don't see any benefit to this guy being in any discussion whatsoever.
Yeah, I don't think he can.
What's up, McToon? MC Toon?
Yo, Joe,
How you doing?
good to see you. That's not me. I
No.
don't have those glasses. Look, these are the sunglasses I have. Can you? These are my sunglasses.
Awesome.
Them are flashy.
So
Them
get
are
it straight.
nice.
Yeah, I know. So
They are.
that's
They're
how I rock.
I was
kind of
just,
Captain America-ish. You'd need a white star though, rather than a.
I'm just playing with
So-
my program here.
So
Okay,
but
Right, so Tony, did you get the information that you were looking for?
I did get the information that I'm looking
Right,
for.
let's
so
do
I
that.
can,
Then I'm going to read super chats and finish up so MC Toon can start his stream.
Okay.
Yeah. So
All right.
if I could just for a second before
Yeah, go ahead.
In about 15 minutes, I'm going to start up with Jose JG Gonzalez. It's going to be fun. We're going to have our Tuesday night festivities. The two of us. It's going to be good. Then
Okay.
I had to move it back an hour from the original start time. I have Wolfie 6020 and Tony, not this Tony that you're looking at with us. Tony Naum, the flat earther from Facebook, who's a lawyer. They are debating. And then after that, I've got Wolfie 3010, also known as Planar Walk, as an after show. So a whole night of fun if nobody likes to sleep.
That's tonight or
So-
tomorrow night?
That's tonight.
Oh, awesome.
So that's I wanted to say two things before Toon takes off. I was talking up Conspiracy Cats as a science communicator. Craig and Toon are extremely accomplished science communicators. And when MC Toon was talking about a Tony from Australia, I think he hasn't organised this with me, and it turned out to be a completely different Tony. Yes,
There's more than one Tony in Australia?
there is more than. Yes, he's an Australian. Yeah,
I thought you all knew each other down there. Isn't it like 12 people or something?
I have
think so.
actually subsequently had the opportunity to talk with Mr. Naum,
Oofed.
and it was very cordial. So he's resistant but cordial. He's a nice enough
Aren't
guy.
they all?
Okay.
Right, yeah. Present your evidence, and then I will read super chats. And Toon, thank you for coming over.
Yeah, thanks for having me. I'll see you on the other channel there.
Yeah, everyone,
Okay.
make sure you're subscribed
Good
to
seeing
MC
you,
Toon
Toon.
so you can go and watch his stream after this one.
But not until
Um,
after this one.
Yes.
Okay, so I'm going to have to do this in a slightly clunky fashion. I'm
ahead.
hoping you can see this.
Yep.
Sorry. It should be showing up a figure of a semicircular obstruction. Can you see that?
Yeah, it looks like a
Right, right.
backwards C.
Yeah. Yeah. So this is an experiment done in a ripple tank. So there's water there. There's a bright light underneath the water, and so that's the initial condition. So this guy is going to cause a point source to appear in the water, and we're going to watch what happens with the ripples. Okay, and now I'm going to have to go on to stage 2. Okay, hopefully you can see he's just created the ripple, and it's spreading out as ripples do, just like earthquake energy does. And hopefully now we've got stage 3 where the ripple is just hitting the edge of the tank. And now we should be seeing, what happens on the reflection. And it's actually quite an unusual feature. Certainly not what I would have intuitively expected, but you get the reflected wavefront. The wavefront that has actually hit the circle comes back as a straight line, as a chord across the top of the circle. You can see it quite clearly there, and actually it's not perfect because the bits near the edges are actually slightly ahead of the rest of the wavefront, and there's also a little bit of a wobble in the middle. But I'm just going to show the fifth one, where you can see slightly more pronounced the fact that the edges are moving a little bit faster. You've still got that semicircular wavefront moving away, but you've got that you've got a pretty straight edge on the inside there. And so that's a physical demonstration of the behavior of the interaction between a circular wave and a circular obstruction. So if the Earth were a disk and seismic waves were reflecting off the disk, this is what we would expect. We would expect to see a reflection off the edge coming back in pretty much a straight line like that. And that's not what we observe. What we observe is that things seem to spread out in a circular fashion, and the only shape that that's possible on is a spheroid. So we can leave aside observations of celestial objects. We can leave aside sophisticated experiments or space or what have you. We can just look at earthquakes, and just looking at earthquakes, you can see that the physics of waves is incompatible.
I can't argue with that. I guess obviously I'm just considering it like what you're saying now.
Can I refute that?
You can try. It'd be funny.
All right. So first of all, why would you think that we would see a reflection off the edge of a circle of the flat Earth?
Because he just showed it happening.
Let me ask you that first question.
Okay, so if you don't have any reflections off the edge of the flat Earth, then you can't explain why we get multiple phases of Rayleigh waves. Okay, we get seismic waves.
Hold on. First of all, your demonstration, show me that demonstration on a ball. What you say? What happened on the ball? Because I don't see you.
Okay,
I didn't see your demonstration. That's how you do science. You got to hold on. Let me finish it. You got to show me what happened on a ball first, because you showed me what happened on a circular disc. Okay, show me what happened on the ball.
So we're considering
we didn't have no earthquake machines close to the edge to Antarctica. There ain't no fucking earthquake machine close to the edge to even get that type of reading.
Earthquake machines?
You said something that's reading earthquakes or something, like you need a type of reading machine close to the edge to get that reading, right?
Okay, let me just share my screen again.
You can't send a sine wave through the whole Earth. That's retarded. You got to be close to the edge to get that reading.
So you say, just because you don't understand physics?
Show me the machine. You showed me some drawings, man. I'm tired of seeing your fucking drawings and cartoons. Show me
just
in real life. Show me somebody taking that reading close to Antarctica.
They don't want to make the observations and keep them.
Here is a graphic.
Another drawing.
What do you want me to do? Do you want me to have on hand, immediately accessible to me?
Model. That's a flat Earth model right there.
That's really not.
This isn't a model. This is a map of where we have seismic stations.
So how you gonna show me science without even a real map to show me?
If you would shut up long enough for me to describe what you're even fucking looking at. Right?
Bro,
you've got no idea what this is a map of.
You've got no idea. Projection of a globe.
You've got no idea what the gray triangles represent, or the red triangles.
Map on the globe. That's what I'm looking at.
No.
So what's the red dots?
You're not.
Well, if you shut the fuck up and listen, you might be able to have it explained.
Stations.
So how can you get a quake near the edge and none of those quakes are near Antarctica?
Okay, if you look at the map,
See,
this
you
is
see
not.
Oh my!
Can you shut up? Can you
Actually, it
shut
was still
up?
my turn to talk,
There's
man.
another.
No, it's
Okay,
not.
there's another. No, it wasn't. I'm still explaining. Here is a map of earthquakes, right? This is a map of all the earthquakes above magnitude 6 that have occurred between 1900 and 2017. And you can see that some of them are quite close to Antarctica. Here's a map of the seismic stations that are part of the International Seismic Congress. I'm actually not sure what the C stands for, but what compendium perhaps. Anyway, you can see that there are seismic stations on Antarctica. You can look at them. They're there. In fact, there's one that isn't shown up. There's a seismic station at Scott Base, which is the American base at the South Pole.
Isn't there one right next to McMurdo Station?
We've got earthquakes that occur near Antarctica, and we've got seismic stations that are on Antarctica. So your claim that there are no earthquakes near Antarctica is false. Your claim that there are no seismic stations on Antarctica is false.
Everything he says is false. So
So and if you want a demonstration, a schematic demonstration, which is probably a better way to go here, of how things would look on a sphere, I happen to have one for you.
he's just going to say, yeah, that's not real. That's just a picture. But yeah, that's how you represent data on a picture.
Hold up, bro. What I was saying. Can I speak?
Actually, no. I'm in the middle of explaining something to you. You can ask questions at the end.
I'm all right. Like, your explanation don't even matter, man. You ain't got no model to present. You scared to bring up a model.
There's the model. Stellarium.
I am bringing up.
Stellarium is the model. Go and have a look.
I am bringing up my
Can
model.
I see a globe?
Yes, Stellarium. Go and have a look.
Okay, this is so here. So here is my model. What you observe is the earthquake. Energy goes up from the earthquake. It causes the P and the S waves interact. They create Rayleigh waves. The Rayleigh waves spread out. They hit the receiver going outwards. They continue to go around. On the left, we're looking at the sphere from side on. On the right, we're looking at the sphere from the top. Okay, they go out. They spread out. They get to the equator. And then now we're looking at, our right-hand thing is from the side. The waves converge. They come in. They converge on the point opposite of our source, which I still marked there. And then they start spreading out again. And you can see I've kept the same notation. The blue is on the left-hand side. The blue is the wave that has already hit the receiver. The red is the wave that went in the opposite direction. And you can see that they're going to come back over the equator. And they're going to get to the receiver. And that is going to happen multiple times for some earthquakes. In some earthquakes, they do multiple laps. Now, if there is no reflection, if there's no reflection off the edge of the disk, how do you get these multiple arrivals at the various receivers? How do you get that? The only way I've heard flat earthers suggested is that there must be a reflection off the edge. I can show that a reflection off the edge does not explain the observations. Now you're saying that you don't need reflections off the edge, then you need to explain why we're getting multiple arrivals at widely spaced points. Also, we can observe the same thing, it turns out. We can observe the same thing as far as sound waves from Krakatoa. Extremely large, back in 1883, Krakatoa went off and it created a very large pressure wave. That pressure wave was recorded at stations all around the world, and the way
look,
it propagated, and
we
it
got
did
another
multiple
question.
laps, and it did multiple laps from multiple directions. So you'd see it coming one way, and then a little while you'd see it coming from the other direction. And you know, here's some graphs of it. But you've got to explain how that is happening without,
No,
you know,
okay,
you've
let's do
already
it.
thrown away
I got you.
reflections.
I got you,
You've
bro.
already
Chill
thrown
out,
away
chill out, chill out,
reflections.
chill out. But this how we're gonna go. First of all, you don't know that Antarctica is the exact edge. Like, there's nobody who proved that, oh, it's Antarctica, you're gonna fall off
I
a
don't
cliff.
care where the
No,
edge
there is
is.
no edge.
It's always going to
If you got
reflect
more
as a straight
land,
line.
First of all, you don't have no earthquakes in Antarctica. That was bullshit. There's no maps to prove that. There's no evidence
you
of
do.
that whatsoever about
Yeah,
any
there's the
earthquake in
stations there.
Antarctica. You on your
The-
red dot map, we didn't see it either. So
There is a
you're
bunch of
still not
stations on the
telling me
map.
why would we see a reflection
There
off
are,
the
in
edge. I'm not
fact,
getting that.
there
That's
are, in fact,
no fair out the
there
claims
are, in fact,
that
You're just denying facts here,
Okay.
Mario.
you're just denying reality.
there's
There
no
are, in
earthquakes
fact,
near the edge.
Yes,
Cut
there
that
is.
bullshit out. Get to something more practical. Where your curvature at? Fuck you talking about? I don't want to talk about no fucking sound waves.
Well, that's
That
because
shit
you don't
don't prove
understand the
nothing.
importance
I
of it.
don't care what you want to talk about.
Gee,
You
keep talking
need
about
to
sound, then I'll
explain.
debunk the rest of your fucking.
You need to explain this. You haven't debunked anything. You're just too stupid to realize that you are stupid.
Demario,
Yeah, I'm just going to
Tony's
leave him
just
muted now
simply
because he
trying
is stupid.
to present something to us for us to consider, and so the questions you have, like about you know, there's no earthquakes by the edge or something like that, I would say that that's probably just a claim that's not based on anything, and
And
Tony
this is
might
coming
be
from
able
another
to.
flat earther.
Yes, so we can look at the MacArthur Rise earthquake that happened on, in fact, why don't I bring that up?
Something does come to mind. I mean, it's not a
Okay,
big deal, but I'll just bring it up
I'm
if you
going
don't
to,
mind.
yeah, sure.
How do we know that those rally waves move through the ground in the same way? I mean, I understand the water, I guess, like if you're talking about, you know, like an ice wall, the edge or whatever, but as far as like going, the ground is made up so different. I mean, bedrock is at different depths and all of that. It would seem to be non-consistent.
It turns out that the physical process that's going on there requires a free surface above it, and the energy ends up sort of constrained there by the physics of sound waves. So
Okay.
so it does. There are two types
Similar
of
to how
surface
it would go
wave.
through anything really, like a solid structure
Yeah,
would
that's
travel somewhat the
yeah.
same way,
So
through faster or slower
yeah,
maybe, but
yeah, exactly. But in this particular case, the surface waves are actually trapped near the surface. That's why they're called surface waves. They sort of create this initial, and there are two types. There are what are called love waves, and there are rally waves. Both of those are named after people.
what is the difference between those that you?
So the difference is the path, sort of the trajectory that a particular particle. For a rally wave, it's more elliptical. For a there's a cat on the the love waves have sort of a more spiky and
It's
they
a
tend to
different
dissipate
pattern.
a lot. Yeah, it's just a different pattern. So what you've got is the P wave. So a P wave is a compression wave, so it's basically a pushing wave. You know, it's stuff pushing through.
And I'm thinking of like, I'm thinking of how sound moves. How sound moves like through the air. That like the speed of sound through the air is, you know, like a jet or whatever will go like 700 and whatever 70 miles an hour. But like down through the water, it's much faster.
Yeah, that's right. And so we're talking about rock, and you can actually do sort of sophisticated analyses of.
It gets more precise, probably.
Yeah. Well, it sort of it gets it gets faster. Through
more solid something.
But you can look at so there are very complicated analyses of travel times, like of seismic travel times, and there's actually something I can bring up for you. So
just different mediums.
so if you have a again, I want to yeah, it's not just there are different mediums, so there are different layers in the Earth, but there's also let me just get this back up.
Okay,
because there's
show this, and then we need to get to super
there's something we
chats.
can do. Okay, I'm sorry this is taking so long,
That's okay.
but there's something we can do that if you want a working model, you need to be able to do this as well.
Good thing I ain't concerned with a working model. No, I'm just kidding.
Yeah, so here is a list of so here are two graphs. On the right is the model, and on the left, top left, is the observations.
And really,
Right,
you only
and-
need 2 stations to get some of these measurements, right?
So you kind of need 3 stations to
3?
work out where the earthquake was.
Okay.
And then you know. But so here's what's happening. So on the bottom is angular distance away from where the earthquake was. Okay, so that's the angular distance, and we calculate that using latitudes and longitudes. So we just use this formula, formula phi equals arc cos, or that complicated thing. That's the angular distance between any 2 points for latitude and longitude. So we know where the earthquake was because we've used a few stations to work that out. Now we can make a prediction for any other stations. Suppose we've got a station at 30 degrees away. Then along the bottom, you go down to that 30, and then you go up. And as you encounter those curves, that's when waves of that type are going to arrive. So the first one you see is the P wave that arrives at about 6 minutes.
Okay, so now no matter where you are, if you
no matter
that
where
line,
you are, if you just go up, and that's the order and approximate time at which those phases are going to arrive.
That's crazy, isn't it?
Yeah, and so when we know where the earthquake is, we can make this prediction for every other seismic station on the face of the planet. Right?
Does that
and
formula? I'm sorry, I feel like I'm cutting you off all the time. Does
No,
that
that's okay.
formula have math in it that is based on a globe?
No, so we do have. Again, if you look at the top left, those dots there are the observations, right? So
Okay.
those are the images that's what we get from the observations, and this on the right is the model, right? This is the model that we've developed to match the observations. And
Okay.
yes, we need a spherical Earth to match the observations. Now we can do the physics on a flat Earth. We can do the physics. We know very well how to do the physics on a flat Earth. And in fact, that's what my PhD thesis was analyzing flat Earth modeling techniques. But they don't work over very long distances. They don't work over more than about 2 degrees or so. They become very inaccurate. And so this, we're at a point here where this is why we think that the Earth is a spheroid, because the observations dictate.
They match with what we would expect. So
exactly.
And I wouldn't say that they dictate necessarily.
And it
works.
Let's go
right.
Yeah, but let's go back to this angular distance. So this formula is, that angular distance between any 2 points on the face of the Earth, right? That's a spheroidal formula. So if that were inaccurate, then the distances shouldn't make any sense, right? The distances that we calculate using this formula shouldn't correspond to reality.
So
now, if you want
points, I'm sorry. Go ahead. I'll wait till you're done. Sorry.
Okay. So if you're, as a flat earther, if you can find any 2 points on Earth's surface of known latitude and longitude where this doesn't accurately estimate the distance between them, then you're done, right? That's it. You know, if this is significantly in error for any 2 points on Earth's surface of known latitude and longitude, then you've proved spheroidal Earth wrong. That's all you need to do.
Okay, but those 2 points.
Any 2 points.
So there's 2 points, though.
That is a place we need to. I think that's a place we need to leave it for now.
Oh,
maybe
sorry,
we could,
Craig.
Yeah, maybe we could carry this on another time. I really do need to finish up now because Toon has started, and it is Tuesday night.
That's right.
So
okay.
I'm good. I'd like to read
Sorry
through
for
super
that.
chats. That's okay. It's always amazing to have you on, Tony, to educate us.
Yeah, thanks, Tony.
I think maybe a conversation
problem.
between you and Effed Up World about this specifically could be helpful for Effed Up World. But we are going to go and read through the super chats, and then everyone can head over to Tuesday night. So I just want to say thank you to Tony, thank you to Effed Up World, and fuck you to Mario. So there's that. Right, Mac D became a new member. Mac D became a member. Well, upgraded to Brawlers. Thank you very much, Mac. Philosopher King Gaming says for $2, what kind of mic did you end up getting? Rip Blue Yeti. My Blue Yeti did die, which is why I've been having slight issues with my audio today, because I got a new mic. I got this one, the Rode, what's it, I can't remember what it's called now, the Rode NT USB mic. Very, very nice, very, very good mic. So hopefully my sound quality should improve.
Have to tune it in.
Yes. Cudlings $5 says, what? Yeah, I agree. Spider for 50 Nokia says, look at star rotation from the equator. Yeah, it kind of disproves the flat Earth. Nick McBay for £2
Not really.
says,
Wait. Can we talk about that?
Maybe another time. I have to get through these.
Okay,
right?
okay.
But it really does disprove things. Nick McBay for £2 says, just order the mug and t-shirt. Kakani Craig. Thank you very much, dude. If you guys would like to order one of these t-shirts or a mug with the FTFE logo on, please go to teespring.com/FTFE. Spider for 50 Nokia said, why on a flat Earth would Polaris dip behind the horizon at any distance? Joe, quickly want to answer that?
As you move away from something, the trees even, or anything, your neighbor's fence, whatever is taller than your eyes between you and Polaris, if it goes far enough away from you, it's called like with radar, what would it be called? It's called ground interference.
Yeah, you don't realize, but you just debunked the flat Earth. Lord Luminous Pooh for $2 says, does anyone else smell burning toast all the fucking time, mate? Fortnite
I smell a
for
burning
$10
dumpster.
says, hey Craig, can you clarify how Universal had their logo as a model of the Ball Earth before we had the first ever pictures of Earth? Asking for a flurf I work with. Thanks, bro. We've had cartography and maps for many, many years. There was globes in the 18th century.
The globe fantasy has been around for a long time.
Globe reality has been around for a long time. Yeah, we've been able to map the Earth for a long time. We've also been able to figure out the sphericity of the Earth. So creating a globe from that was pretty damn easy.
It's a good thing to imagine. I've heard.
Brad Dubay for $2 says, Effed Up World, the secret identity for the Waffler.
For the what?
The Waffler, the worst Batman villain ever.
He's
Sun Express.
He's a Batman villain, is he?
No, probably not. Sounds like he could
Well,
be.
Wouldn't I be the Penguin?
There's a mystery there is a Waffle Man in or the Waffler in
Waffle Man.
Mystery Men.
No, you're right. There is the Waffler in Mystery Men. Mystery Men was great. The shoveler, I think the best superhero.
Yeah,
The shoveler.
I can shovel.
That's right.
Like no one. The Sun Express for $10 says, dear Flurf, the measured Earth circumference at the equator 40,000 kilometers. The measured Antarctic Circle circumference 16,000 kilometers. Explain the discrepancy.
I can't. I don't think you'd have to. I'd probably have to travel it to be able to explain it.
Yeah, well, luckily the Antarctic is sailed around every 2 years in a boat race. So, AZ the Kid for $1.99 says, "Where's the poll option for I am Flat Earth Man?" No, the poll option was simply I'm Batman or I am Iron Man, and it was 50-50. So So fuck all you Marvel fans, I guess. No, kidding. Mike 71.
I'm going to
$5
climb
says,
the Tower of Babel while we're chatting.
why do the stars go in the opposite direction in the southern hemisphere? Magic is clearly the answer.
They don't.
Well,
That's what I wanted to talk about. They don't. They all rise in the east and set in the west anywhere on the earth.
but it's based on
it is
the
not
way that you're
switching
looking at
direction
them
at the
that
equator.
they appear to change. That's the thing. Ron Mox
Yeah,
for
Just
£5
because you
says-
turned around, you went
Yeah.
from facing north to
it's a-
facing south. It's simple. Of course, the direction in the apparent rotation is going to be the opposite way, no matter what. You turned around, you're looking from north, and then you turn
No,
180
so
degrees.
You can prove that incorrect, right? I mean, you can start north of the equator and move south of the equator and face north all the time, and the apparent orientation in terms of clockwise to anti-clockwise is going to switch. Some stars are going to appear to rotate clockwise, and some stars are going to. Well, you can try it.
Well,
and,
just YouTube some time lapses at the equator, and you'll see what the stars are all going the same direction. They're all setting in the west. As you look west, they're all setting in front of you.
you
all
need
the way
to
the right.
you
and to
need
the
to
left.
try and you need to try and explain that to Mario, because he will disagree with you violently. Anyway,
Well,
Mario's-
I'm just
'cause
going
Mario's
off
a
my
dipshit.
observations
Yeah.
with my telescopes.
yeah, no,
and
no,
what-
no. You're. So how close to the equator are you? Is the thing.
I'm at 45 degrees.
Okay. So
Polaris is at 45 degrees in my sky.
yeah. So I would suggest that you need to actually make some observations closer to the equator.
So
to
you're
some
saying that the
southern
stars wouldn't
celestial.
be setting in the west?
They will be setting in the west. They'll always set in the west. The
Yeah.
question is that so when you look up, right, we're moving to we're rotating towards the east. So as you look up, you're going to see stars, I think, moving clockwise.
Well, we can just look.
Yeah,
just look.
the stars are appearing. The stars will appear to trace a circle above you in a clockwise direction. But if you're in the southern hemisphere, it'll be the opposite sense. They'll
It
appear
has
go
to be because you're
anti-clockwise.
facing the
They'll
opposite direction.
still, yes,
okay.
but you're facing in the opposite direction because the Earth is a sphere. You
Or
can't
just
be-
because
you know,
you're facing south.
No,
No.
that would be. But
Right,
you
okay.
still get the
Let's
same
not
effect when
get
you
bogged down
face
this
north,
'cause
right?
No, if
Try and
you're in the
explain this to
southern
a flat earther
hemisphere,
can be
you
very
In
can't
the
see
southern
the.
hemisphere, it's not a
polar.
law that we only look
Okay.
southward.
Oh
No,
definitely
okay, so
Anyway,
let's go. Yeah, I suppose
Anyway,
it could go on too long.
Yeah.
Let's talk
Robots
sometime
for
soon.
£5. Asteroids not man-made and move through the sky like clappers. Yes, they do. Cinema Control, $5. What's a polar orbit on flat Earth? A Pac-Man model? Yeah, I'm going to be debating the dude that thinks the Earth is literally like Pac-Man. I can't remember his name. Ronnie something or other. That should be next
No,
week.
that's a good question. I couldn't explain that one.
Brad Dubay, $5. Effed up world. Could you provide anything to back up any of your made-up hypotheses? No? No conviction? No evidence? No, no.
Sure, whatever you want to say.
String News 1 for $2 says mass has the electrolytes that space-time craves. That's a secret. No one's supposed to know that. NA for $6.66. Hail Sagan. I dig it. Hail Satan. Elizabeth Sylvester, thank you very much for your first super chat. For $2 Canadian says, I love you, Craig. You are so amazing. Go get 'em. And I love you as well. Thank you very much for being an awesome supporter. Johnny Marr, £5 says, effed up, why can Tony see the Magellanic Cloud, but you and I can't if the Earth is flat? He would give the same answer for as he did for Polaris earlier.
The
with
Magellanic
perspective and
Clouds?
stuff. Yeah,
I don't
it's
get
a,
it.
it's a small.
So
You're
the
just saying from
Magellanic
where we are.
Clouds- Yeah,
It's a small orbiting
from where
galaxy
you
around
are.
the-
Okay,
the,
well, they're too far away.
So it's the same as the Polaris argument in the sense that we see them in the southern hemisphere. You guys in the northern hemisphere don't see them.
And you guys can.
Not as far into the northern hemisphere as we can see them into the southern hemisphere.
With a
anyway.
decent telescope.
Anyway,
you can see it, basically.
Again,
Masturbator, $5 says.
a discussion for another day.
Yeah.
Yep.
Sea Whiskey got paid laughing at Flurf's best birthday ever. Happy birthday, Masturbator. Logical Hillbilly for $5 says, why waste time with Mario? He doesn't know anything. He won't shut up long enough to learn anything. Kick him and bring on Mallory. I'm going to bring Mallory back. I think it's time. Jason Hammerquark for $5 says, great show once again, Craig. Hope you're feeling a bit better, mate. Stay strong. We're all here for you. I'm getting there, guys. I have been having some issues with mental health and struggling to deal with chronic pain. But the amount
Well, if you have
of
Mallory, she's going
support-
to beat you in a debate,
I
so
know.
you might
Oh,
want to
that'd be
wait.
twice. The amount of support that I've received through DMs, emails, comments on YouTube, skywriting, all sorts, it's amazing and makes me feel loved. So thank you guys. I have really struggled, but your support has got me through it. And thank you very much. I can't say anything more than thank you from the bottom of my heart. Stringer News 1 for $5 says FTFE 30 minutes ago. I read super chats in 10 minutes. Yeah, I know. Sorry.
That's probably my fault.
Esteban Amravoch for 50 ARS. Not sure what that is, but thank you. Just joined the debate. I'm sure it was a dumpster fire. In another question, does anybody know something about JM Truth? I know lots about JM Truth, including the fact that he is the biggest dumbass on the planet. Please go and check out my several videos about him, including the one with nearly 200,000 views, which he told me I'm not allowed to have up because it's defacing his property. Because he's a fucking idiot.
Did you guys see Simon Joe?
Simon, yes, very good. Simon Joe. But that is going to be it for tonight, guys. I want to say thank you very much for being here with all the support, the super chats, the members, the chat and everything. Thank you very much for watching my video earlier. If you haven't seen episode 60 of Flirts Are Idiots, definitely check that out. Mrs. Fight destroys Eric DeBay. Tony, thank you for coming on and being the only real person here once again. Always a pleasure.
You're welcome.
And thank you,
it's
Effed Up World, for...
Always nice.
Thank you very much. And thank you, Effed Up World, for being civil, even if, you do hurt my brain.
I don't mean to, Craig. Thanks, Tony, and thank you, Craig. And yeah, it was a good conversation.
All right, it is Tuesday, so please go and head over to MC Toon's channel to watch him talk with Jose JG Gonzalez. Then there is a debate between a different Tony from Australia and Wolfie 6020, and then Wolfie 3020, otherwise known as Planawalk, will be coming on for an after show. The link to that is being spammed in the chat by my mods. Thank you everyone once again. Remember, stupidity is not a right. Fight the flat earth. Fight the flat. And my outro's paused. Hey. Fight the flat. 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 Fight the flat.